Good morning, everybody, from myself, Fabrizia Battiston, Head of the Relations with ESA at ASI, the Italian Space Agency. I'm National Delegate to European Space Agency Council and to European Space Agency Program Board of Earth Observation, where I act also as a Vice Chair. I would like to thank the Conference Committee to give me the opportunity to chair this session. So welcome, everyone, to the climate session of the New Space Economy ExpoForum 2021. Nowadays, climate is one of the utmost topics with relevant socio-economic impacts at the attention of the governments all over the planet, with clear implications on space economy. This climate session is a full and exciting program encompassing interventions concerning various themes, from science to economy, from legal matters to the new space. Today, we have a very important outstanding speakers, and so I would like to involve them immediately. But before that, I would like to present briefly the speakers. There is Simonetta Cheli, first intervention, and then Professor Battiston, and then Juliette Lambin. Unfortunately, she is sick today and she cannot join us. And there is a speech of Alessandra Vernile, and then Miss Maria Fabrizia Buongiorno, and then Professor Andrea Taramelli, Miss Irene Benito, and then Mr. Michael Davis from Australia, and then Mr. Andy Court, Dr. Diane Howard from US, and then the last speaker is Mr. Adnan Rais. I would like to start immediately. The first speaker is Miss Simonetta Cheli, Director-elect of European Space Agency Earth Observation Programs and head of ESA Esrin Center in Frascati. She gained more than 30 years of experience in European Space Agency. ESA is strongly involved in providing its contribution to monitor the climate change key parameters through its own initiatives and international cooperation. Today, Simonetta will focus her intervention on climate and new space, two important subjects of this space decade. Simonetta provided a pre-recorded video of her intervention. So I bring you her warm greetings, and I kindly ask the organization to launch her presentation. Thank you so much.
Good morning to everybody. Good morning for this conference, where I would have liked to be with you in person, even remotely, but live. And unfortunately, I cannot be with you today due to some previous engagements. I'd like to thank the organizers. I'd like to thank ASI and actually Fabrizio Battiston, who is chairing this session on climate change, and thank the organizers of the European ExpoForum on New Space Economy to have invited me. I'm Simonetta Cheli from the European Space Agency. I'm the head of Strategy Program and Coordination Office, and as from the 1st of January 22, I've been appointed Director of Earth Observation at the European Space Agency and Head of ESA in Italy. I will be based in Frascati in Rome to be there as Head of Esrin and representing ESA there. So today, thank you. I've been invited to do this intervention together with other colleagues and friends. I see them on the program about Earth observation and climate change, and of course connecting it to the topic of new space, which is the topic of this conference. So I'll introduce you to the context of what we are doing at the European Space Agency for this. The context, unfortunately, it's a context of climate crisis. We're in a world where we have more and more a trend of natural disasters. We have seen this summer the natural disasters in Central Europe, the fires in Greece, the fires in Canada, and we have unfortunately a climate crisis ongoing. Here you see Sir David Attenborough. He actually opened the COP26 conference in Glasgow, where we were present as ESA, as observer. We're always going to COP meetings, and he presented the science evidence and the science evidence on the current climate crisis, which is something where we basically look at the accelerating climate change issues, and we see how these issues are really threatening all of us. So what do we do with space? to support all of this, to support these activities in the field of disaster, in the field of climate change in particular. With these emissions, we take the pulse of the planet. So not only we are getting a view of what is the state of our planet today, we see here different images of the Earth, which are basically the pulse of the Earth seen from different perspectives, from different angles of our satellites. We do, in fact, have a lot of satellites at the European Space Agency. We have 3 lines of activities, one on the science missions, which is called the Explorer missions, and there we look at the scientific objectives related to the environment and also climate change. We have many already up and in operation, even some who have finished their lifetime, like GOCE, which has given us very important data related to the geodesy of the Earth and also ocean circulation and impact on climate change, of course. We have SMOS mission on soil moisture. We have Cryosat that has recently celebrated its 11th year and has given us very important measures on ice mass and ice mass evolution. We have the Copernicus Sentinel family mission. Here we have 8 satellites in operation. The last one was launched last year, Sentinel-6 and Michael Freilich, and it gives us relevant data on the basically sea level height and the evolution of this important parameter for climate change. We also have the Meteorology Mission, and there this is what we do with EUMETSAT, and it's here an image which is an emblematic one on COP21. This was in Paris in 2015, where basically there were arrangements taken in relation to climate change, and the COP21 agreements are still monitored in terms of implementation, and space there can provide an essential support to the monitoring of the implementation of these agreements, which actually made a provision to contain temperatures within 1.5 degree compared to the beginning of the industrial era. And also this containing of the temperature is something that we can look together with greenhouse gases with satellites. And we are actually building a satellite dedicated to the stocktake of COP21. Global stocktake will be done the first time in 23, next one after 5 years in 28, and we are building a dedicated mission in the context of the Copernicus expansion mission dedicated to CO2 anthropogenic measurements. In support of climate, we have developed a program in ESA. It's called CCI, it's Climate Change Initiative. It's actually a program that integrates data from different data sources, not only Copernicus Sentinel data, but also data from science missions and also data from partner missions to support what's called the climate variables. In fact, we support over 20 climate variables with these activities, and this program is all about not developing and launching satellite, but integrating the data to support parameters, indicators on sea level rise, deforestation, temperature, quality of the air, and out of the over 50 climate variables of the United Nations Framework Convention on Climate Change, these are the ones that we're actually working on. You see here an example of carbon dioxide. Carbon dioxide, as you know, and as it was clearly indicated at the last COP26 meeting, has had a steep increase over the last 10 years. We are looking at daily atmospheric carbon dioxide that has reached levels in the last 10 years that are around 400. You see here the reference ppm, and actually it's really something that has increased in terms of 9% ppm in terms of percentage in the last 15 years. So we cannot afford to actually increase more, and we need to monitor the situation, the evolution of carbon dioxide. We can do this already with existing satellite measurements from various partners like the OCO mission from the US, and we will develop the CO2 dedicated mission to be launched in a few years. On forest, COP26 agreed on a declaration about containing forest and on forest degradation at the time span of 2030. On forest degradation, you see here the value of using data, optical data in this case. Here you have Landsat data. You also have Sentinel-2 data combined to look at the region of Rondônia in Brazil over a period of time of about 20 years, and you see the degradation of the forest. And this is very important, especially in areas related to equatorial regions. And there again, the satellite has a strategic importance to support monitoring and implementation of arrangements, typically the Declaration on Forest that was also signed by Brazil and India at the last COP26. Glaciers is another example. You have probably read or heard about the UNFCCC report that was published in August this year. It was the report number 6, where basically science was presented in terms of evolution on climate change, and most of the science in such report was based on data coming from Earth observation satellites, in particular a lot related to evolution of glaciers in Arctic and Antarctic regions using data from Cryosat, and also using data from Sentinel-2 and Sentinel-1, and also on the coverage of land. So a strong increase of the use of data and integration of data sources from space for the report of UNFCCC. And here you see the example of the retreat of the ice front with different evolution from 95 to 2019. So you see the impressive retreat in terms of glaciers, and over 9,000 gigaton of ice have been lost from glaciers since 1961. So this is a parameter that actually we have been following since 91 also with our ESA satellites, ERS, MBSat, and then Sentinels, of course, more recently. Sea level rise, I mentioned you Sentinel-6. This is a satellite, the last one of the Copernicus Sentinel series that was launched in November last year. It's a collaboration between the European Commission, EUMETSAT, and NASA, who provided an instrument and a launch opportunity. And here you see basically not only from Sentinel-6, of course, actually this is probably from the previous data sources, the evolution of sea level rise in the last 30 years. And you see this until 2019, so before we launched Sentinel-6. And the average sea level rise has been until recently of the order of 3.2 millimeter per year, and the trend is now increasing, and you see here the figure of 4.8 millimeter per year, which is the recent trend in terms of sea level rise. Sea level rise that is caused by two parameters, mostly by the ice melting, of course, but also by the increase of the temperature of the oceans. And all of this you are able to measure thank you not only to the recent ESA missions, but combining those with national French mission, US missions, and having data over a long period of time, for example, from JSON or TOPEX Poseidon, integrated into models of evolution and of climate. In ESA, we also work on new space. You've probably heard about Agenda 2025, or the DG was published when he arrived as new DG earlier this year. We are going to work very hard on the development of new space activities, in particular in the field of Earth observation, as this is also the topic new space of this conference. We are working to be an ARCON customer for new initiatives on the commercial side related to EO, and we recently had, in fact, the signature of the first contract of a contributing mission to Copernicus. This was done with ISI, a private commercial company doing radar imaging that is now contributing to the whole basket of a portfolio of data available in terms of data sources in the context of Copernicus, and this has been also an effort by ESA to support new commercial initiatives. In the context of new space, we are also developing new models of satellite mission, not only the traditional ones, the big satellites that we've always developed, but we have started with the last ministerial to develop scout missions. These missions are smaller missions of a much smaller scale also in terms of budget investments, typically 30 million euros per mission. They're scalable if successful. They have also anyway a scientific value, and they're based on small-sat, CubeSat format. And we have just recently signed the first contract of the Scout-2 Hydrogen-SS mission, which is developed with SSTL. So this is a new model of ESA to support new space developments on top of the anchor tenancy role. New space is also bigger satellites. It's Arctic Weather Satellite is a satellite that we started to develop recently. It's a new concept in terms of cost effective and in terms of management effectiveness of managing a program. It's a satellite constellation that will provide high resolution humidity and temperature sounding in all weather conditions. It's dedicated to the Arctic region, and it's an interesting model of new management scheme with the industry in terms of more flexible schemes and more fast development schemes. And that's also another good example of new space in our Earth observation context. Last but not least, we have developed with the FFSCAT mission, FISAT-1. FISAT-1 has been a demonstration of technology and innovation. So mounting an artificial intelligence on a satellite, which was the FFSCAT mission. This chip, AI chip, has been successfully mounted and launched on board the FFSCAT and has enabled to do pre-filtering of cloud imagery and to demonstrate actually artificial intelligence on board a satellite. Last but not least, we have a program which was born a few years ago following a mission by ESA to the Silicon Valley, where we were looking at the reference model all over the world, including the US, that we could get inspiration for ESA programs. It's an industry support mechanism. It's a support to commercialization. It's a co-funding scheme with the industry that supports technology and also application and services, and it's actually managed by the PhiLab, which is located at ESA Esrin in Frascati, and which is a sort of a innovation lab to support entrepreneurial initiatives and competitiveness of the market. And this, of course, is also connected to the topic of today, which is climate change, because we're also demonstrating at the PhiLab activities and services which are very, very closely related to climate change. So thank you very much. I wish you all the success for this conference and this session. And again, I'm very sorry not to be able to be live with you today. And I wish also the best to the next speakers, who most of them I know very well and have been working for many years. Thanks a lot.
Thank you, Simonetta. Thank you very much indeed. Yes, we have seen the tremendous satellite fleet of Earth observation of the European Space Agency, and also the future of these satellites is very rich indeed. Taking the pulse of our planet, you said, Simonetta, and we have seen also the contributions provided by ESA in the climate change, monitoring parameters and essential climate variables. And you have shown, Simonetta, some example about glaciers and sea level rise. The next speaker will focus the attention on the CO2 emissions. So the carbon dioxide is the focus of the next topic. And I have the honor to introduce Professor Roberto Battiston, the chair of this conference. He is full professor at University of Trento, and he was former president of ASI, the Italian Space Agency, the place where I work. So today I will talk about the importance of the CO2 for understanding the climate. The floor is yours, Professor Battiston, and thank you so much.
Thank you so much, Fabrizio, for this introduction. And let me share my screen and start with the presentation. So do you see my first slide? Hello? Do you see my first slide? Do you hear my voice?
Yes, yes, indeed.
So let me try another to share again my screen. Sorry about this. So share screen. Do you see?
Unfortunately not, Roberto.
Do you see it now? Do you see it now, my screen?
Yes, yes, it's coming. Yes, yes,
Okay.
okay. Very good.
May I start with that? Sorry about this little problem. So I would like to make some scientific introduction to the issue of climate change. I titled my contribution "The Whys, Hows, and Whos of the Climate Change." So some elements which are related to what is going to be discussed in this session. We know that during the last century, the average temperature of the Earth has continued to increase steadily, and the detail of this increase has been monitored more and more precisely using satellite data. And every year now, since several years, the current year is the hottest of the last 5 or 6 years. So the situation is degrading at a fast pace. Consequences of that, has been said repeatedly, are of various kind. Altogether correspond to about 1 degree of increase of the last 1 century. And this contribute to all kind of phenomena, for melting polar ice to increasing sea levels, as has been reported recently in the previous talk, drought, issue of the agriculture, and fires, a lot of fires during the hot seasons. And this is the issue that we have to face altogether. This has been also a subject of tremendous social concern.
Professor Battiston,
Yes.
Yes, the slides is fixed, is stopped with in the first page, the first slide.
Still at the first slide?
Yes, if you can push on F5, it's maybe the presentation can start. Yes.
So you don't see my presentation running?
Not anymore now.
What about that?
Was...
What do you see now?
Just you and me. You have to start the presentation first.
So I do start the presentation,
right?
And then?
And then select the window.
And then start the, so let me try that. Sorry about that. Start the presentation first. I go here, but I cannot, if I start the presentation, I cannot select the window. So I'm here, share, slide, no, my computer. Sorry about that. So share screen.
Yes.
Window, this one. What do you see now?
Yes, it's starting. And then now you have to press F5. Or yes, or yes, it's correct, yeah.
Would you see the second one?
No, it's the first slide. The first slide.
Yes, it's the stop on the first one. It's not moving.
It's not moving, yes.
So I will do the following then. I will share in this way. F5, you said.
I don't know what the problem is. I invite Federico.
Let me solve that. Just a moment.
Yeah.
Okay, we do it like that. Do you see my slide?
Yes, just the first slide.
What about the second?
Not yet.
Do you see the second?
No, it's stopped on the first. Federico, can you help Professor Battiston?
Hello, Professor. Good morning. Try to launch the presentation and then reduce it to icon.
But if I launch the presentation, I have my screen completely filled, and I don't see anymore the control of the.
Maybe you can move. I don't know. I see you have a Mac. Like you can just move with the fingers on the pad on different windows.
Yes, I'm not into the window. So what I should do here?
Just stop the screen sharing on StreamYard. Actually, I'm gonna. Okay, then launch the presentation again anew.
I launch the presentation.
Okay, now with the fingers, just go back to StreamYard page.
I did, yeah, but I'm unable to launch the presentation here.
Sounds strange. If you want to send them to me on my email, I can just share for you.
Yeah, but then I think we are going to lose some time. I will do that right now.
Yeah.
What if I do slide? I do that. Upload file. There is a limit of 50 megabytes. Okay, so I propose, Fabrizio, let's move to the next speaker, please. And I will come next. We are losing too much time. Okay?
Okay.
Thank you.
Thank you. That's the live session issues. And I asked to Alessandra if she is ready to present a speech. Just Alessandra, tell me if you are ready.
Can you see me?
I see you, yes.
Okay, good morning, everyone.
Very good. Just introduce yourself. Alessandra Vernile is a project group coordinator of the Space Generation Advisory Council since 2018. In this position, she manages the 11 SGAC project groups, one of the pillars of the organization. Today, Alessandra will present the climate change-related initiatives launched by SGAC and the project group. So thank you so much, Alessandra, to be here with us today. And thank you for your availability to start your presentation immediately. So the floor is yours. Thank you.
Thank you very much. I hope you can see my screen. Can you?
Yes, indeed.
Okay, so thank you very much for this short introduction. So I'm here to speak on behalf of the Space Generation Advisory Council. Just a quick overview on what SGAC is and what we do in relation to climate change. So first of all, for those who are not very familiar with SGAC, SGAC is a global non-governmental and not-for-profit organization and network. It basically represents students and young professionals between the age of 18 and 35 years old to the United Nations, space agencies, industry, and academia. It was created in 1999 in conjunction with the third UN Conference on the Exploration and Peaceful Use of Outer Space, so UNISpace 3. And the idea of SGC is, first of all, as I said, is a network. So create a global network of students and young professionals, active and passionate about space, who wants to really impact. So leave an impact actually in the space sector and be committed to the sector itself. The SGC also helps in connecting and create, again, a network, a wide network among other peers and also top space professionals from different organizations. And I invite you actually to visit the SGC website to check who are the supporters of the organization. And at the same time, SGC wants to give the next generation of space sector leadership opportunities and a voice in the global space policy. The network of SGC is pretty wide. The organization covers 6 regions, about 168 countries, and the number of members is constantly increasing. You can see that really like every almost every inch of the world has been covered, or there is some members of SGC over there creating a small, let's say, community and group of active and interested and passionate students or young professionals in space. SGC relies on 5 pillars. So the first pillars is events. Then we have the project groups, and I'm going to talk about project groups very soon, in particular related to their activities and for concerns of climate change. Then another pillar is professional development, scholarships, and policy and advocacy. SGC also is a permanent observer status at the UN COPOS, and also a consultative status at the United Nations Economic and Social Committee representative, ECOSOC. And in particular, SGC presents the outcome of all of its conferences and projects at the Scientific and Technical Subcommittee at COPOS, the Legal Subcommittee, and the General Assembly. The organization has a physical office in Vienna, and this also explained the closeness with the UN. Before moving to climate change, just a very few words on the pillars. So I'm going a very step back. In general terms, I mean, the 5 pillars of SGC are very much important, and you can find some of them now explained in for what concerns climate change, because they really help like the participants to the events or the active volunteers. So I mean, honestly, I'm a volunteer in SGC. I'm not employed by the organization. My everyday job, it's still in the space sector, but I'm a volunteer. And as me, there are multiple volunteers. You saw before the number of members. And all of us, we are supporting the growth of the organization, but at the same time, there is a big group of volunteers that are undertaking like positions within the organization. So they are active members. And this can help you in, of course, develop professionally and to grow also in terms of network and bring back, let's say, to your everyday life, or actually to your everyday job or to your university studies, what you learn in SGC. And just to move to climate change, because as I said, some of these pillars are relevant in the discussion related to climate change. So climate change is basically the challenge of the next generation. So it represents indeed one of the biggest challenge, and the consequences, we are seeing the consequences. Professor Battiston just mentioned that every year is the warmest year of the previous one compared to the previous one, and this is one of the biggest effect, and actually also causing other having other consequences, in particular in some regions of the world are heavily paying these consequences. Young generations is actually, let's say, a victim of this climate change, and all these students, and with students I'm referring from pupils to PhD researchers and students or young professionals, are trying to shape their futures, let's say, leveraging on the idea that climate change is a challenge and that can turn into an opportunity. And space, and now more than ever actually, is starting to become part of the discussion on how can it support climate change. So space services, space data and technology, how can help in, let's say, mitigating the effects of climate change or just observing the effect of climate change. In this sense, in the frame, of course, of SGAC, we believe that space technology in relation to climate change can have three main impacts in awareness raising. So SGAC can help in this sense, building a momentum, and also contribute to the global discussion. So let's start from the awareness raising. So SGAC, and this is mostly related to the event, since, well, a little bit before the COVID actually, so let's say since February, it started, February 2020, it started to organize webinars. Webinars, we are seeing now, they are very powerful because, of course, they can help you outreach to a wider number of participants. But in particular, during COVID times, so in particular during the first wave of COVID, the number of webinars in SGAC increased massively, and a series of a series of webinars related to climate change have been organized. You can see here some of them. So we have the SG France. SG France is a regional event, so that targets France in particular and French members of SGAC, but actually, again, it's open to everyone. SGAC is very international, and it talks about satellite for climate change. So we have three experts, and you can see our three women, all of them scientists, and discussing how space can help in facing climate change. Then there is another webinar that was organized last March, another one organized in the frame of the SGC for North Africa. So in total, around a little bit more than 130 webinars have been organized, covering multiple regions of the world, and with a very incredible actually numbers in terms of views and participation. Then SGAC has every year the Space Generation Congress. It is the flagship, let's say, event of the organization, one actually of the flagship of the event of the organization, and usually is held in conjunction with the International Astronautical Congress. So, and actually just a couple of words about this. In 2020, the event, of course, turned into an online event. In 2021, we were able to meet together in Dubai, so physically, partially physically, and so it was a blended mode. So part of the participants were physically Dubai, and another half was connected from remote. But that was first of all a great opportunity to meet up again, but also was the moment to discuss with high-level speakers and subject matter experts from academia, industry, or space agencies on the key issues from the space industries, the challenges that are faced, and one of the sessions, actually the working group of the Congress, was dedicated to climate change and sustainability, and it was supported and sponsored by Planet and by CNES. And again, I invite you to visit the website to learn more about also the outcomes of the event. Then SGAC supports since 2019 the Space for Youth competition. Space for Youth competition is a competition organized together with UNOSA in collaboration with SGAC, and this year was supported by the US Permanent Mission to the international organizations in Vienna, and also by the UKSA, so the UK Space Agency. This year the topic was space as a tool to foster mitigation and adaptation. It's of course a paper competition. As you can see, more than 200 essays have been received from more than 70 nationalities, with a very interesting coverage in terms of gender balance from women. So, and also the three winners are three women. So this is also something to be proud of. And you can, of course, have a look and read actually the three essays that won the competition through UNOSA website and SGAC as well website. Then it comes to project group. So SGAC as one of the pillars actually is represented by the project groups. And project groups, let's say that they are a little bit like the core of the organization in terms of research. Currently, you see now that we have 10 project groups. Actually, we have an 11th one that is going to be added very soon. As you can see here, these project groups, they try to cover multiple in a very wide way, multiple areas of the space sector in a way that really can provide to the members of SGAC a very general, more than general, actually a complete overview on the different aspects of the space sector. You have space safety and sustainability, NEO, space law and policy, space exploration, cybersecurity, commercial space, medicine, satellites, small satellites, actually, space technology for Earth applications, ethics and human rights, and the 11th one will be on diversity and gender equality. And these, each group has the possibility to work on specific researches and to develop conference papers, scientific articles, participate and organize events such as also webinars. So some of these project groups have their own webinar series. And some of these groups are working on the topic of climate change. So let's start from the Space Safety and Sustainability Project Group, for instance. One of the latest articles that has been produced is Space Technology and its contribution to the challenge of climate change, in particular related to floods. So how the space technology can help climate issues here on Earth. Of course, this is an interesting article because, first of all, it's on a blog. On SGAC website, which means it's definitely an article that could be addressed to multiple audiences. So you can have an audience more like a student audience, to a researcher that wants to that is outside, for instance, from the space sector, but it's interested in learning more about space. And then finally, you have also young professionals that maybe are approaching the topic for the first time. So it's a very interesting article, and I invite you everyone to visit the blog of the Space Safety and Sustainability Project Group, or if anyone is interested, to get in touch with them. Then, of course, there are also research, and I mentioned before that among our project groups, there is the project group on space technology for Earth applications. And of course, I mean, they are working quite massively on the topic of climate change, and in particular, in relation with disaster management. Here you can see this is one of their major work that I'm going to explain you very soon. Sorry, it's this one. There is a mistake with the slides, which is the image that you just saw. So the real-time flood risk assessment in Cameroon, in this case using social media, so using crowdsourcing data, which should help to identify more flooding events than compared to those officially documented by the Cameroon Meteorology Department. To do this research, of course, the project group didn't work by itself, but was supported endorsed actually by the International Geological Correlation Program of UNESCO. And they had the opportunity of analyzing some optical and satellite data. So very interesting project, and the fact that it was done by volunteers within the organization is incredible, because it shows the commitment and the interest towards the topic. Another project that was developed by the Space Technology for Earth Application Project Group was supplementing Earth observation with Twitter data, in this case to improve disaster assessment. And the case study is the Bobcat fire in California. In this case, the result of the project has been presented at the International Astronautical Congress of this year in Dubai. A lot of data were collected through Twitter, so in particular following the hashtag California Fire, and this helped in, let's say, created fire severity map using data from Landsat and relying, as I said, on the social media data. So this is also pretty interesting because it provides you a different perspective on the topic of climate change, or more than topic of climate change, on a particular niche within, actually under the umbrella of climate change, which is again disaster management, and how much and how much social media, social media is actually providing relevant information to the general audience, also on what is happening worldwide, again in relation to climate change. Then we have another project group, actually, is a space law and policy, which is probably one of the historical project group of SGAC, that together with actually the support of the human rights and ethics within SGAC, developed and actually investigating and promoting human rights protection through space technology. But in particular, one of the latest work that they do is try and find the link actually between human rights and environmental protection and the different legal instruments that are used by nation states or international organizations to address human rights issues and climate change using remote sensing technology. And this because the objective was to measure the impacts on the ecosystem and natural resources, on the physical infrastructures and human settlement, and finally on the livelihoods and health and security. This is what the project groups are doing. Again, I invite you to visit the SGAC website and the project groups webpage to join and to follow, for all, especially young professionals and students that are participating today, to follow SGAC if you're not member, even join the organization. And thank you. If you have any question more generally related to the organization, please write to info@spacegeneration.org, or if you have more specific questions related to the project groups, please get in touch with me to my email address. Thank you very much.
Thank you, Alessandra. Thank you so much. A very interesting presentation, a very comprehensive presentation. Really, thank you. The point of view of young generation is vital for the future of our planet. And we have seen how the new generation are contributing to foster the attention on climate. So thank you so much.
Thank you.
I would like to go back to Professor Battiston, and the issue should be solved now. And so, Roberto, please, the floor is yours.
Thank you, Fabrizio, again, and thank you also to Alessandra to be so fast in replacing me on an emergency condition. It was really very interesting talk, in addition to be really fast in acting. Thank you so much. So we can start with the first slide, please. Okay, so I will try to address a few elements of scientific background of what is going on, also some policy issues about climate change. Next one, please. This is a video, should start, please, with a click. Okay, so this is a large Okay, I mean, this is not a really lucky day today. Okay, anyway, there is don't try again. This is strong evidence that every year in the last several years has been the hottest year with respect to the past one. This is the evidence of climate change, and every year we have a record year, and this is also influencing, of course, all kind of physical phenomena, from melting of ice to flooding to fires to increase of the water level, as I was mentioned before. Next one, please. Next one, please. The reason for that are related to the fact that the Earth as a planet has not a stable climate condition, has not a temperature which is stable over the long period of time. If you look to this chart, which is showing the last 500 million years of temperature values as a function of time, you can see that if you go to the paleoclimatic information, like the Permian, the temperature was oscillating between -4 degrees with respect to the current temperature to +14 degrees. And you can imagine over those periods how extreme were the conditions for whatever was habitating the Earth, plant and animals. But we were not there. So this tremendous change, which also could influence the water level in the ocean by tens and hundreds of meters, where we're not under a condition where we were forced to live with. If you go to closer period of time, even to the last 60 millions, you can see that the temperature from a peak at about 14 degrees in the Eocene, it started to go down steadily, but this is again over 50 million years, and the human species were not around. If you go to the Pliocene, which is the last 5 million years, you can see the temperature still going down. And when we get to the Pleistocene, where the human development was taking place in the last million or so years, you can see that was oscillating systematically below zero, with up and downs, which were quite substantial of various degrees, but always on the cold side. And if you come to the last 10,000 years, this is the point which is relevant for our civilization, the temperature started to stabilize around what we call the zero reference for today's, and has stayed there for the last 10,000 years. And as you can see, all the civilization of the human species has taken place in the last 6,000 or 7,000 years under extremely stable temperature condition. Changes of half a degrees were causing either drought or glacial condition, and the prosperity of all the civilization were related to this incredibly stable condition of the temperature, except for, if you go to the very right, a steep, very quick change which took place in the last century of about 1 degree. You can appreciate this 1 degree change in the last 1 century, how large it is with respect to the history of humankind and civilization in the last 6,000 years. So this number is small with respect to the past millions of years, but it's extremely large and very, very fast with respect to the last 1,000 of years where we are living through today. Thank you. Next one, please. And if you amplify the last 1,500 years, you can appreciate that even better. We do have a hotter period during the medieval period of around the 800, 1,000, and this was fairly hot and very issues of drought and water need, and you had a small glaciation period in the 1600, which caused tremendous loss of agricultural capacity and famine. But in the last century or so, you can appreciate again through very direct measurement which have been performed, the temperature has increased very significantly in a very, very short time. The derivative of this graph shows how fast it was. Next one, please. Next one, please. And this is, has been mentioned this morning repeatedly, can be associated with a rapid increase of CO2 in the atmosphere and other gases like methane. And what it can be appreciated that this change over the last 60 years was only about 30% of the existing gas. And we're talking about part in a fraction of 1,000. And this is small phenomena, which, however, is over all the places and causing the systematic fast increase of the temperature on all the Earth surface and regions. Next one, please. Of course, this is a tremendous issue and is a source of very large social inequalities. This chart shows that number one, the disasters, which are these blue dots of floods or green dots of hurricanes and other extreme phenomena, are all over the places in the north, in the south, in the equatorial region. But the intervention, which is the ratio of insurance policies which has been set to repair for those damages, is totally unbalanced. In the north, these are approximately comparing to the damage caused in the south basically are non-existent. This is basically an indication of how unequal the global change effects are. Next one, please. The scientific basis of that is very solid. It's now nearly 60 years where people are discussing about where the CO2 goes, which is the contribution of mankind, and which is the imbalance which brings more and more CO2 every year in the atmosphere, and also greenhouse gases. Next one, please. And this can be subdivided into contribution due to gas burning, to liquid burning, to solid, meaning carbon burning, to industrial activity like cement production and other things. Altogether, you can see that the million of metric tons of carbon per year in the atmosphere keeps steadily increasing from the 20s of the last century up to today. Next one, please. Now, which is the consequence of that? So there is a tremendous activity in simulating, trying to understand what is going to happen, and the big alarm which has been issued starting from the COP15 in Paris, but even before, of course, it is that again, going this way in the future, it is projecting a warming that with respect to the current baseline of pre-industrial activities, it could exceed 4 or 5 degrees, with tremendous consequences all over the places. And this chart, which has been which is an old chart which was in 2018, was projecting this kind of behavior without any intervention. The gray band, the gray band is going to happen with the policies which were decided at that time was the blue band. And some optimistic policies were going even better than that. But you see all these increase in temperature were exceeding, except the very optimistic one, by far the 1.5 degrees goal of the Paris Agreement. Next one, please. If you go to updating this chart to 2021, November 2021, what we do see? We do see that still policy and actions projected to the end of the century are exceeding the 1.5 degree significantly. There is a band of 2.5 to 3 degrees. And there are other targets, more or less optimistic, but you can see there is a big gap between the goals of the Paris 2051 agreement and the reality. But you can also see at the beginning of the period a kind of strange behavior. The increase which was historically going on kind of stopped in 2018, 2019 because of COVID. So COVID is a kind of a slowdown the overall economy all over the world, broke back this curve for some couple of years, and it shows some very deep truth that only a global, very strong, a very dramatic and negative effect can bring back these values into a behavior which is expected if we want to respect the Paris Agreement. And obviously, we don't say that to support that COVID is needed to save the Earth from global change, but it's just say how strong the impact has to be on the commercial policies, industrial policies, and social policies in order to go down into meeting the Paris Agreement. Next one, please. The gap that today we have with respect to the Paris Agreement is very large, it's substantial. This is why there is such an alarm by various people and the various organizations. Next one, please. And there is a way of measuring that with one simple number, which is the global temperature increase by the end of the century, according to expectation. The Paris Agreement goal was 1.5 degrees. Today, even the most optimistic scenario are kind of set at 1.8 degree, but we understood that the reality of things as today, it is more like 2.5 or more degrees, which is really unacceptable. Next one, please. We can define a climate action tracker rating system, exactly considering which is the goal the various countries are setting in order to meet those Paris Agreement goals. Next one, please. And you can find out all over the place which are the countries which are comparing with these goals, the ones which are almost sufficient, the ones which are insufficient, highly insufficient, or critically insufficient. And you can imagine, you can immediately see from this chart that all the countries in the world are below sufficiency, and very few are almost sufficient, but none of the large one. The large ones are either insufficient or highly insufficient or critically insufficient, like, for instance, Russia. Next one, please. And you can see that due to in various areas of industry, like aviation. Again, you can see this drop due to COVID, but the bouncing back after COVID is expected to grow dramatically in a field, aviation, which is highly impacting on greenhouse gases. Next one, please. Shipping, again, you see the drop due to COVID, but again, the projected increase in the coming years bring immediately to the end of the century to very critical situation. Next one, please. And if you do look at the target which has been announced at the COP26 very recently, still these are targets, goals, wishes, dreams, if you like. A number of countries have submitted new targets which are better than the previous one, but some of them, like Russia again, Australia, and Brazil, did not. And even in the intention, those targets are not announced or not matched, even on the intention by the various major countries. Next one, please. If you can look in detail, the policies announced where can bring us to in the coming decade or so. You can see Europe, which is labeled as insufficient, are definitely going down with respect to historical behavior. So it's behaving relatively well, but still insufficient. Next one, please. If you look to China, which is a kind of flattening, but not going down, is defined as highly insufficient in the coming decade or so. Next one, please. Russian Federation, which is going up, is critically insufficient also because it's starting from very high values. Next one, please. And the US, which is one of the major players in this field, is going slightly down, but still considered insufficient. So this gives you an idea how difficult it will be in the coming decades to implement policies which will contain and reduce the climate change phenomena. Next one, please. It is important to understand how difficult it is to deal with CO2. I hope this movie can start. Can you try, please? Okay, the movie is not starting. Anyway, this is a supercomputer simulation which is showing how complicated it is to track CO2 emission, absorption, diffusion over all the Earth from different continents and at different height in the atmosphere. Is a continuous changing phenomena. It is evolving day by day, hour by hour, season by season. This is the reason why space can be so important to accelerate the action to contain and to modify climate change, because there is no possibility to calculate the CO2 distribution and emission without monitoring day by day the emission taking place at different locations, in different regions, in different time. This is the fundamental reason why tracking greenhouse gases from space not only give you the tools to model this evolution and the intensity of the phenomenon of greenhouse gases, but most important for the future is giving you the tools to understand what each country is doing, is implementing as policies is concerned with respect to the declaration and to the goals. And this is a fundamentally important tool to keep under control the evolution of the climate change. Next one, please. So these basically, another click, please. Maybe this is going to start. So not even this one. Anyway, so this gives you an idea why space will be an accelerator to address climate change. We do need those data, those precision data from of Earth observation in order to provide powerful and effective tools to the decision-making processes and to the monitor climate change phenomena in the coming decade. Thank you so much.
Thank you, Professor Battiston. Thank you very much. We have been waiting for a few minutes, but we were compensated by this amazing presentation, very, very complete, starting from the trend of temperature and CO2 along the ages of the Earth, with clear economics and social implications identified nowadays, and most of all, the importance to have common and shared policies in the short term. And that's the challenge of the future, the clear challenge. So thank you very much, Professor Battiston, again. And we are a little bit behind the schedule, so I would like to move to the next speaker. It is my pleasure to introduce Ms. Maria Fabrizia Buongiorno, Director of Technological Research at the National Institute of Geophysics and Volcanology. From 2020, she is responsible of the INGV Center for Space Observations of the Earth. In June 2021, she was appointed as president of EGEOS. Fabrizia has more than 30 years of experience in the field of Earth observation missions and data processing for environmental and natural hazards applications. Today, she will present a work on Earth observation integrated services to monitor and mitigate climate change effects. Fabrizia, the floor is yours. Thank you.
Fabrizio, thank you very much for the introduction, and I thank you to everybody for have the opportunity for this presentation. Let's try to just a second that I don't see the presentation. I don't know why. The presentation is on. Today it looks not so easy.
Yes, this is the effects of the climate change, maybe also in the technology.
No, but I made the testing and everything was okay.
Actually, so, the presentation was on screen just before.
Yeah, it's on screen, in fact, but I don't see the.
Try again. Yes.
I see, but I don't see the presentation, so maybe it's somewhere else. Let's see. Maybe if I go to the presentation.
Just look at the message of Federico in the chat. Maybe it can be helpful.
Okay, let's see.
Share screen.
Okay, I see it now. Okay.
Okay.
Sorry, but I don't know. This morning is a little bit difficult. So after the presentation of Professor Battiston, I would like to go to present EO integrated service to monitor and mitigate climate effects. So going towards the operational service as EGEOS is doing. So that's what I'm going to present. I will be very short, of course, on climate change effect, just an overview. I just want to focus on what are the market and what are the situation of space technology services, and then present some examples of what EGEOS is providing to support the climate change effects analysis. So, first of all, as we have just seen in the previous presentation, we are, of course, facing an increased population and human activities. And that's, of course, as it's been shown, contribute to the climate change. And of course, implies the increase of threats and risk for infrastructures and the sustainability of development models of human society. So what we have to take into account that since we are living in a global environment and all we see increasing of surface temperature, sea level rise, extreme weather events, earthquakes, volcanic eruption may amplify the effects, both in the dimension of space, therefore in different territories, and in time. That will have long-term effects. But also we are living in a very marvelous technological evolution, so that we should take advantages of these many increase of knowledge and increase of availability of new technologies as space. Just to show what Professor Battiston was trying to show with the movie, it's not. I just pick up 2 slides of that same movie. The center of the last century, the 20th centuries, and our century. Just look at the temperature changes in this slide. What I want to remark that. It's not only that there are few degrees of say mean temperature, but those few degrees impact the northern regions, and that's one of the real big threats that we have to take into account. It's not an homogeneous increase of temperature.
Sorry, Ms. Buongiorno, I think you need to start the presentation anew because we're just seeing the first slide. I'm here to help you. Just interrupt just stop the sharing.
It doesn't go on?
No, we just see the PowerPoint presentation not starting on the first slide.
So, because I am on, I can go back.
That's, yeah, try this again. Start the presentation on StreamYard. You did fine on the first time. You just clicked the wrong button.
You see?
Not yet.
It's strange list. Just a second. It was going on at the beginning.
Yeah, but you clicked the wrong button and you stopped the presentation twice in a row, so that's why it was working fine.
So now it's on at the first. Maybe no, I just.
Now I see nothing. Now I see nothing because you need to start again. You need to start again the presentation.
Okay, just I start again the sharing.
Yes, please.
Okay.
Okay. Okay, don't click the blue button. Don't click the blue. Click the nascondi one, the close one in the lower bar.
Okay.
Okay, and now you move to your presentation. Launch it. Okay.
Okay. So I was here talking about the temperature. Did you see it?
Yeah, it's working fine.
Okay, sorry. So I was just showing that the temperature is affecting mostly the north, and the change of temperature, the north part of the globe. So just to look also at another important things of the trends of what we see. we might say that there is a variation on the solar activities, but just this plot shows that the increase of temperature is not following the solar activity. So all these effects are now very clear, have been presented. The carbon dioxide, we know, but that's of course produce extreme events, and that's where we have to use the space technologies and try to support the monitoring and the management of the world itself. What the benefits of space technology to measure climate change indicators? Of course, there are already a lot of information, and we have a lot of possibilities to use this very wide range of different measurement coming from the space. So we can evaluate. We are very now close to 90% to know to do accurate weather forecast. We have an enormous number of satellites, and we can measure a lot of climate variables. And that can give this information can give support to the decision makers. But I want to emphasize also that the spectrum of space business is changing, and there is a lot of new components coming in, and small satellite constellation, miniaturizing of instruments, and this change the service. And we have also to face with the climate change also these very rich changes in the new space era. So the market is very heterogeneous. It's a competitive landscape, and there are many players, global and more regional, and there are so many satellites available, and there are multiple, constellation and small sat constellation. So this is a very complex, system at the moment, and also it's a complicated also for the foundings. And we have if both the public and the private sectors, that's to find the funding to invest, to develop technologies and services, have to look to many different instruments that coming from EU, from Israel, if you talk of Europe, but also national and regional level, and private funding. And there is a gap also in this area where the finance sector doesn't the finance sector doesn't know, lacks the knowledge about the finance, and finance lack the knowledge of space. So navigating in the system is very complex. Anyhow, we had to do our best to use and to proceed on this new era of space. From my point of view, it is very important that we develop a fully integrated system, and that has to include public to private partnership and the integration of research, industry, space agency, and end user, because everyone has his own role. Let's now have just some example, as I said, of what EGEOS, that is, as you see, public is a partnership. It's a company where we have the 80% of Telespazio, which is Leonardo and Thales, and 20% of the Italian Space Agency. So it's an example of public-private partnership in this case. What is important to address all the facts and the problems that were showing in the previous presentation. We have to combine all the space system. I don't show here the upstream system, but of course we have to organize all the service value chain and have the operation of the ground systems, how to access the data, develop the services, and provide the services to the end users and stakeholders. So just I want to just go back to this scheme. So going to to the ground station capabilities, that in our case, EGEOS is it controls the Matera Space Center, where there are an Earth observation data hub, there are 24-hour operational services and space geodesy services that is, of course, an activity of the Italian Space Agency. So the space geodesy is why the Matera born as a center, and still is very important because space geodesies can support also the analysis of the space, they say the climate change, but especially of the Earth processes, and including the sea level rise and many other information. So Matera is the core of acquiring the data that will be used for the services that EGEOS is implementing and offer to the stakeholders and users. So we have a lot of different satellites that are acquired, and first primary the Cosmos Sky Constellation that is that is controlled and distributed by EGEOS, and then we have, of course, Sentinel-1 and the SAOCOM and other missions that could be acquired by the center. So the Cosmos Sky Ground segment is the important hub and system, and so the Matera station is having a very important role on this to control and acquire and distribute those data. Of course, there is activity that regards some monitoring, in this case, the maritime surveillance services that, of course, are more related to the problem of the high activities on the sea. As Professor Battiston said, the charge of CO2 by vessels is an important source of CO2. So that's monitoring on maritime monitoring is, I think, an important step also for to address the climate change. Let's go to one of the services that EGEOS is offering to Copernicus is the rapid mapping services, and that is really address some of the effect of global change. It has 24-hour operations and worldwide coverage, and has to produce fast products in about 3 hours, and can address different, phenomena, fires, flood, earthquake, storm, and others. So just 2 examples. Wildfires, we had many activation in 2021, just that represent the increasing of fires due to the temperature, the rising of the temperatures. And so the use of different satellites to assess the damages made by fires using Sentinel-2 and Pleiades. And so this is an active service that really can contribute to monitoring this phenomena. The others that also is related to climate change is flooding, and also there are the services is produce a large number of products in the year 2021, and that's also demonstrated the needs to this kind of activities that Copernicus implemented because of the severe phenomena that are caused by the climate change. So that's some other also using SAR, Optic, and area, so an integration of different sensors on different platforms. What then is needed, because as we see the quantities of data and satellites provided by satellites can really so rich number of products that what is really need is something that could organizing all these services in a single platform. So EGEOS, as others, invested in a clouded observation platform that can permit the users to have a single area where they can find data and also develop services or buying services. So that's an example that include inside the clouds, there are vertical services, as you see here: maritime, defense and intelligence, agriculture management, asset management, and emergency management. And this is an online marketplace, and but it's something that is growing and is say including more and more activities that can be also shared for research and say to use artificial intelligence and machine learning to have more and more integrated data and provide information. So this is how it operates. It has an operational marketplace and also an operational processing platform, and of course give also an help desk to help the interest users to access, to navigate into the different parts of this platform. What is available, of course, is to access EO data by the archive or tasking the data, and then, of course, get information on products and combine different services. And I want to emphasize that all this data has to be analyzed also by the point of view of time series. So that's available in CLEOS. So what is I was just saying that is also a place where research of new services, a new system to analyze a multi data and define different parameters is really a place where we can it is possible to do this kind of developments and transferring learning and collaborating with different labs that could make a better use of a different platform and different data. The last example that I want to bring to the attention is a big, say, a very large European project that is that depends from the European Environmental Agency, and then is the ground motion service that is just being implemented last year, and EGEOS is the coordinator, but is not only, and include all the mainly expert and providers of the analysis of SAR data is based on Sentinel-1, and what is very important that is a project that will is at say European level, so it's not regarding one region but all the European area, and is also important because there are we will provide velocity maps, and all the products will be calibrated and provided say, so it is included in a 50-kilometer grid GNSS model because is needed, of course, that the products have to show a high reliability. So this is implemented already, and we can see what is the delivery schedule that will start from next year and go through the 2024. So that's a very important, I think, activity that include the efforts of many industries and research also institutions to control the the ground motion at European level. So I would like to arrive to conclusion and remarks. Of course, there is a lot more to say on this in this area, and the possibility to grow different services. And but in my perspective as a researcher and in earth science at the moment, and in my present activity as president of EGEOS company, I think I would like to emphasize the strategic importance and value to develop and strengthen the partnership between public and private sector to fully use the space technologies and address climate change. As we see, it's a complex climate change, and it's complex looking how to get the advantage in the use of all this space data available. The synergy and integration between different competencies among and better planning of integrated upstream, midstream, and downstream activities could provide more effective tool to the decision maker and stakeholders, therefore identify mitigation action to reduce risk and develop resilient strategies. I think also looking to the presentation of the colleague about the young that are that one side that they will say be the victim of the climate change, but also they are the most important people that we have to engage to react to this what is happening. I think we should invest in training and information activities toward the exposed population, as well work to reduce the impacts on human activities and on Earth climate. And so the importance, and I would like to encourage the engagement of new generation in pursuing the understanding of Earth environment and processing, using new technologies and particular EO data. This approach, from my point of view, will bring different benefits, including maintaining strong and sound scientific research, as well ensure the continuity of the technological developments. So I think that is all for myself. I thank you very much for the attention, and to do a better job for stop the climate changes and the increase of surface temperature, and uses as best the new technologies. Thank you very much.
Thank you, Fabrizia. Thank you very much, and thank you for highlighting the importance of services, of the Earth observation integrated services exploiting satellite data. This is one of the key elements of Copernicus, one of the most relevant components of the European Union space program. And this allows me to introduce my friend, Professor Andrea Taramelli, next speaker. Andrea is an associate professor at University of Advanced Study of Pavia and associate researcher in remote sensing and surface process at Institute of Environment Protection and Research in Rome. He is also scientific director of the Inter-University Center of Research on Applied Remote Sensing to the Space and Earth Observation, and national coordinator of the Copernicus User Forum. We spent together a lot of time at the Copernicus Committee, exchanging our views with the other member states of the European Union. And today, Andrea will present the Italian Copernicus user uptake strategies for climate services. Thank you, Andrea, to join us today. The floor is yours.
Thanks, Fabrizio, and thanks for inviting me. And I'm really happy to be, talking about what Fabrizio was already introducing about how the Copernicus, but the user consultation is driving the climate services. I'm going to share the presentation. Not sure if yeah. So I will introduce what we are doing at Italian level with the Italian User Forum in order to show you the uptake strategies for climate services. Of course, I'm happy also to do my speech after the presentation of Professor Battiston, of Fabrizio and all the other speakers, because what is really important to bring to the attention is the fact that when we talk about climate services and climate change, we're talking about like a very transversal thematic area. So we need a lot of scientific background, but also a lot of needs and user needs highlighted from different community. So just a quick introduction on what is the National Copernicus User Forum. It was it was set on the stage on 2014 to support what we call the Interministerial Working Group aimed to identify a number of programmatic initiatives to maximize the national returns of operational services. So what we have in mind, it was really linked to what Copernicus program was giving to the different member states and what are the user need and user requirements on the national level. So we launched the user forum with a Copernicus National Workshop in June 2014, and one of the major issues and thematic area we were really starting from scratch was really related to climate change, air quality, and all the environmental problematic thematic area. So the need and the goal of the user forum is to prepare together to disseminate information about all the ongoing and foreseen activities of Copernicus bodies. As Fabrizia was already introducing, it's really important that member states contribute to the European regulation. And then, of course, to collect and coordinate in a coordinated way what the national user community needs, trouble, and expectation for what can be used in terms of like space, Earth observation in general, and so on. So this is really important because set the scene where the users are the center of the development, and this is one of the major issues with the space economy. So it's important to stimulate a qualified, authoritative, and coordinated national use of services offered by the program, and of course to support what is called the user-driven approach with respect to the national European space-based development. This is really important because we link the space development to the European regulation or framework directive that has to be implemented. It's important also to remember that the user forum has a strategic role that has been confirmed from the actual space committee at the national level. So just a quick view of what is the structure of the National User Forum is made by institutional representatives. So technical people, a representative from all the ministry. Of course, we need commercial representative, industry, but also commercial representative, research, representative, and also all the national representatives with the European delegation. Not only in Copernicus, but if we talk about climate change, all the national representative into the WMO, into the ECNWF Council, and so on. So the discussion is really bringing to practical problem, and of course it made use of the national network of Copernicus Relay that is made by sort of like regional and local office that are uptaking the information to the regional scene to what Copernicus is, but also the National Copernicus Academy Network. So this is just to introduce that you have a European and a national government, and the National Copernicus User Forum is made by consultation board that are set it up within the Copernicus User Forum, and you can see that it's related to security, to what is a thematic area of agriculture that is really linked to the climate services, but also related to environmental protection, coastal, but also dissemination. And we are using also what are national boards that are not made for Copernicus, but are working as a consultation board for geology, hydrology, and of course climatology. And under climatology, of course, we have linked and discussion related to air quality, CO2 production, and climate. So this is really important because and the GreenNet is the network that is dealing with the CO2. And of course, the Copernicus networks. So you can understand that we have more than 900 participants with around 40 institutional and representative and 645 people in consultation board. So we have 75 national academy and 10 national relays. One is, Fondazione Amaldi. And of course, we have a lot of people to discuss about like climatology at national boards. So it's 172 people. So you can understand how this consultation board has to work in a sort of like finding the user need and user requirements, which are the application and the services. And of course, the discussion is also dealing to what are, you know, the improvement that we can take in climate services using Earth observation. So what is the user level? What is the national level in terms of user need and obligation, and bring into the European level what we are doing. So it's really important, as also Fabrizia was already underlined, the role that has also the research community to accompany the user to refine the requirements on the top of the most advanced technology. So in this sense, also into a projectual and experimental phases. But it's really important to underline that what is really dealing with you know, the user need is what are the European obligations that we have to implement at national level. So what is the scientific and technology innovation related to Earth observation to improve what we have defined the national monitoring operational services. So what is the market uptake and downstream development? So the user consultation has, I have a clear task. So defining what is the user requirement collection. So which are the user community that are dealing with, in this case, climate services, which are the EU, but also the national policy identification. So what we have to implement. So bring an interaction matrix to define the feedback collection for user requirements, then sort of like prioritize which are the requirements, which are the parameters that has to be taken into consideration. And as the previous presentation were underlining, it's important to take into consideration also what young people are, you know, asking for the definition of what are the operational services. Of course, producing a specific services with innovative requirements, so producing a gap analysis for the operational service implementation. And of course, making a gap filling, what is the data integration for the development of non-existing services. So prototyping a specific services based on what is, you know, the technology development, also using a new satellite mission, and what is producing also, you know, the evolvement of the Earth observation. You have to take in consideration when we talk about Copernicus and when the discussion is related to climate, you have to figure it out when we are talking about like satellite, but also in situ data and also a lot of like modeling. This is really important. So what are doing the Operational Climatology Board that is composed by research center, but of Environmental Protection Agency, university, but also civil protection department, regional and local governments, private company. This is done to make activities that are categorized by climate monitoring. So what are, you know, monitoring services, both atmospheric and surface parameters, what are the observational analysis, climate variability and current trends that they are doing, and which are the climate prediction, monthly, seasonal, decadal, and multi-decadal. So in order to bring, you know, and to make an analysis and which are the real user requirements, the Climatology Board made a first survey on what is already available in Italy in terms of climate services. And they have like delivered a first issues of like already operational climate services in 2016, and then we had released a second issues in 2020. So in this white paper that we have bring to the European Commission, but also to all the national agency, are described all the available climate services that are already running in Italy. So what are the information that are already available to make a climate change scenario based on you know, real measurements. So the point was the climate group results make a wide range of operational climate services that are available at national level. And these are, you know, from real time to multi-10 years. So this was made in order to monitor, when we're talking about climate services, hydrometeorological and climate trends and fluctuation, evaluate climate change impacts, support decision makers. Of course, decision makers are to make decision based on scientific analysis and operational services. This is really an important step. So the use of information derived from both satellite data, but seasonal forecast and climate projection are, of course, highly increased in the last period, and they are going to be increased. I would like to mention that right now, since almost 1 year, we have Italian Italian Meteo Agency. So linked to that huge work, it was created an Italian agency that is bringing what already Copernicus at European is already giving, is also integrating all the in situ data, the national remote sensing data, all the other data and information. So we have created a strong coordination among all the different public institutions, whether a related climate office and research institute. This is really important because I'm stressing the issue that when we are talking about climate change, we are talking about like several thematic areas. And you can see that we are dealing with agriculture, but we are dealing also with the National Civil Protection, with the Ministry of Transition, Ecological Transition, but also ministry that usually can use this information, like the Ministry of Culture, to make scenario about how the climate change is impacting the cultural heritage and so on. So you can understand how it's complex, but how this coordination is bringing a lot of information in terms of climate services that can be useful taking decision. And of course, the Climate Consultation Board is really working in synergy, what is also developed under the Operational Hydrological Service Board. That is a national board made of the 7 river basin district authority. If we talk about, climate alert, but also meteo alert, this is really important. So you can start to understand how much is the contribution, in this case, is federating 21 regional hydrologic offices and 3 national entities, that is the Environmental Institute of Environmental Research, ISPRA, but also the National Civil Protection Department, but also the Aeronautical Military Meteo Office. So the main activity was also in this sense, making a coordination on hydrometeorological monitoring, making the data publication and data quality control, and making guidelines about that. So it's sharing the best practice and training course, because also this was one of the major issues. And as I was underlying, the need analysis of the buyer groups were then used to figure it out how to build an hydrometeorological climate services and a water resource services that is sharing all this information and making better and requirements for availability of new satellite data and new monitoring data. The same approach was used in the atmospheric board when the proposal for an Italian network for greenhouse gases and essential climate variable monitoring. As you can see, the network, the GreenNet gas monitoring, supported by still very different public institutions, but not only public institutions, because we have also private reality and industry that are contributing to that. It was really giving to Copernicus CO2 monitoring service, but also to the program of World Meteorological Organization, what are the in situ data that can be used for the greenhouse gases. And also this group was also providing a CO2 white paper, so that is giving the national situation, so the national, let's say, snapshot on what are, the national emission inventory, reporting on CO2 and other greenhouse gases and essential climate variable. If you think what was the discussion at COP26 in Glasgow, this is something that really brings to the discussion not only proposal for activities, but really a quantitative analysis on what can be used in order to take all these decisions. This is really important. And of course, related to that, and maybe a lot of people cannot make the link directly, we have to face reality that it's the Ministry of Agriculture and Forest that is really doing the same type of approach. So also them are contributing to what is the hydrometeorological climate services, but looking to what is the common agricultural policy into post 2020. So what are the framework directive and the common agricultural policies that are asking for measurement in terms of climate services, but also Earth observation data and information that can be used in order to implement the common agricultural policy. In this sense, I'm just citing another working table, that is the coastal board, that also in this case the user national forum has bring to the European Commission what are the coastal products and services in Italy, but also building up an action related to the Copernicus user uptake with France, with the Med7 member state, in order to bring and highlight which are the coastal initiatives that can be used for the blue economy in the Mediterranean Sea and beyond, including the climate change scenario. So these make the importance of why the Copernicus User Forum is bringing a lot of information in terms of which are the policies that can be implemented and which are the space observation and the Copernicus information that can be used in this sense. And last but not least, we have included in the discussion, in the analysis, what we have called the Valorization Board. So not only the public institution and the public ministry, but we have started to integrate also big company, small and medium enterprise, but also small realities like spin-off and startups in the discussion, because most of the time we have seen that a lot of data analytics in terms of climate change can be already, not maybe it's too much solved, but at least discussed with some reality, and it's one of the base of the the new space economy that you are discussing in this session. So the Valorization Boards is putting in the discussion what are the suppliers, what we call the enable, but also the aggregators and the developers that really bring the enrichers. So it's important to have a sort of map on what is already available, but it's important to have at the discussion table also what are the developers that are maybe not really into the climate change community, but developing some new analytics can bring a lot of new information. So this is just to let you know that this discussion is really also dealing with operational climatology, of course, environmental protection, operational hydrology, and agriculture. And we have a lot of, also private and commercial entities that are participating in this discussion. And we think that this is some practical example, what is, the demand and the offer discussion in terms of new space economy. So what is the sustainability if we talk about like climate services in terms of what is needed and what can be the solution that also the the private sector can bring to the discussion. So just to close, the National Copernicus Academy is also, as Fabrizia was mentioning, dealing a lot with the information, but also in the formation of the the young people. So it's really making a lot of training and session about climate change, and putting what was done in 2019 in the Polytechnic of Torino. But we had several other meetings organized also from the Copernicus Relay. So also this network can bring to the attention a lot of activities, so the information on what is going in terms of animation at local and regional networks. This is really important, because if we want really a huge of users that is going to, let's say, pay for use about all the information that the Earth observation, the space sector can bring to the daily life, it's really important that this is really improved. So also in this case, we have several meetings that we're trying to uptake, so to let's say aware that there are a lot of activities in this sense. As a final, we are also using what is the framework partnership agreement of Copernicus user uptake. So also the Copernicus, the Commission is bringing funding to make all these activities happening. So the framework partnership agreement is really making a possibility for making the national user uptake, some global action, but also some action related to business solution and innovative products and application. And I would like to stress that in a 2-year work program, the total cost for Italy was quite a lot, the requested funding. So it's really possible to brings funding to do this activity, to stimulate the new space economy. And of course, I'm highlighting also that the European Commission has created a new EUSPA, that is an agency located in Czech Republic, that is bringing new activities for the business solution in that direction. Based on all these quite extensive activities, we have also contributed to what is the Mirror Copernicus program. So that is part of the national program of the space economy. And I'm bringing to your attention this because the Mirror Copernicus is based on two major legs. So the industrial actors that will have like the maximum funding, but also based on what the public actors, so what are the needs from the user, public requirements, and this is going to guarantee the sustainability. The implementation is really important because as this image is showing, the buyer groups, so the public institutions are the core for the set requirements, but then there are several, the industry, the research institution, of course, the Ministry of Industry and Sustainable Development is the project management with the Italian Space Agency, but we have involved also what are let's say European skills. So the the European Space Agency, but also ECMWF, that is the coordination, is the entrusted entity that is already implementing the climate services at European level. So linking really the national level to the European level. Also, this is important, not to replicate what is already on the market, but downscaling the information at European level to the national and to the local one. This is really important. So just to conclude, the research and development is really including most of the scientific reality in Italy, and this is really relating what the buyer groups, so the major ministries, are really linking. Just to finalize a clear, example that is already implemented and is going to be, improved with the Mirror Copernicus, but not only with the Mirror Copernicus. So the Italian Space Agency and the Italian Environmental Research Institution have already built a pre-operational service that is using the high quality data information at European levels, downscaling using the in-situ network, also giving more information using input emissive database that is including, and this is an operational, pre-operational monitoring service that is up and running. And that is going to be also used for estimate the PM10 and PM2.5 at national level. So this is all the information that each single major of the city can have every single day. And this is based on what Copernicus is already providing and what also the Italian community. And of course, with the Mirror Copernicus, what is going to be asked to the enterprise, how we can improve, how can we stimulate other, initiative in that sense, how we can bring new information in that sense. And all this data and information will be open and freely available. Another thing that is important, and I will conclude, Fabrizio, is the fact that we are going to use the next generation EU. So the funding that we are going to bring, and there was a huge discussion in that, how we can build on the top of that in both the three segments, on the upstream, on the midstream, and the downstream. So how we can use this funding to integrate with much more information. So also in this sense, the new space economy will have the possibility to integrate all these major services that were already, highlighted and defined and already partially implemented. That we will start with the Mirror Copernicus, but we will use the next generation EU to put, a huge funding also for the enterprise in the new space economy to provide a sustainable, Earth observation network system, both for the public institution, but also for what is the market. So bringing a sustainability of the investment. So thanks for your attention, and I leave this.
Thank you, Andrea. Thank you so much. Thanks for this comprehensive presentation and for sharing the path and the great effort requested to gather user needs and how to translate them in operational services. This gives me the opportunity, Andrea, to move to the private sector and introducing the next speaker. So thank you so much, Andrea, again. Next speaker is Irene Benito. Irene is a senior product marketing manager at Planet. Today, she will be speaking about tools of new space companies like Planet offer to make a difference in the fight against climate change and to ensure the utilization of this potential to the maximum. Climate change is a global matter, and now we start to move across the planet and to meet Irene in San Francisco. But at the moment, it is deep night there, and so she prepared a pre-recording of her intervention, bringing her warm greetings. I kindly ask the organization to show the video. Thank you.
Good morning, everyone. It's a pleasure to be with you virtually today. My name is Irene Benito, and I work as a senior product marketing manager for government at Planet. Many of you will know us as a leading commercial provider of Earth observation imagery, and actually the first company to succeed in imaging the whole of the Earth's landmass every day. I do wish that we were meeting today in person, but still, I really look forward to a fruitful discussion coming out of this forum. And at the end of the presentation, I'm going to be sharing my email, which is irene@planet.com. So please don't hesitate to send me any follow-up messages or questions. Let me now share my presentation. Today, I'm going to be speaking about why we need space and specifically why we need new space to fight climate change. It's clear that climate is at the top of the global agenda. And as we saw during COP26 in Glasgow, concern over the topic is only growing. This is the case not only for governments and nonprofits, but also for businesses and civil society. Europe, and particularly the European Commission, is a leading actor in this field. With the Green Deal, the European Union wants to become the first climate neutral continent by 2050. Space is an essential tool to achieve this, and particularly Earth observation can be game-changing. And that is what I'm going to be focusing on today. In this slide, you can read, you can't manage what you don't measure. And this is something that drives our work at Planet. Climate change is incredibly complex, a challenge which is multidimensional and planetary in scale. We won't be able to manage or attempt to fix the problem of climate change without first being able to understand and measure the issues at hand. Earth observation data is a foundational tool to help this happen, because it's wide scale and it's consistent globally. And with this, it can help construct uniform measurement systems across the board, which are relevant to all countries and all players. And here's where Planet comes in as a key enabler to build the necessary measurement systems. Our mission has remained the same since we were founded in 2010, to image the entire world every day and make that information visible, accessible, and actionable to anyone. Our first years were about making the world visible to everyone. To do this, we had to reinvent aerospace, creating a highly cost-effective manufacturing process, dramatically reducing the cost of satellites, and making mission operations scalable through automation. The last years, we have focused on making the data accessible. We brought the data out of the labs of data scientists and geospatial engineers and made the data easy to access, machine learning ready, and available through an innovative subscription model. Today, and the focus for the next decade, is to make the data actionable. We're going to do this through the use of artificial intelligence and the creation of an ecosystem for developers that will then empower decision makers in businesses and governments across a vast array of vertical markets. We accomplished the mission to image the whole of the Earth's surface every day 4 years ago. And a crucial part to this success has been Planet's pioneering of the Agile Aerospace methodology. This involves adopting an iterative software development methodology to how we produce hardware. In our case, we rapidly iterated the design of the Dove spacecraft. Doves are our crown jewel, and they're really the reason why we can image the whole surface of the Earth on a daily basis. We iterated the design of this spacecraft 15 times over the last 7 years, incrementally maturing it and adding capabilities with every design revision. A key part of this approach is leveraging R&D spending in other industries. For example, by using batteries developed for electric cars or processor and solid-state drives developed for tablets and laptops, we can take advantage of the billions of euros that others are spending on R&D. In this video, you can see part of the crucial part to achieve our first mission to image the whole of the Earth's surface every day. Back in 2017, we had our biggest launch ever, 88 satellites on an Indian PSLV rocket. At the time, this was the largest cluster of satellites ever launched on one rocket. And it was this launch that got us to our full constellation and meant that we could eventually image all of the land on the planet every day. This is an animation that shows our two constellations. The first one, the Doves or PlanetScope constellation, is the result of the launch I just spoke about. The Doves orbit the Earth with their cameras, which are pointing down and turned on whenever they're in sunlight. They orbit on a sun-synchronous orbit. The Earth then rotates under the satellites every 24 hours, which allows us to get a full scan of the Earth every day. These satellites have 8 spectral bands, matching most of the Sentinel bands except for a few. The other constellation that you can also see is high resolution, offering 0.5 meter per pixel. This is our Skysat Constellation. These satellites are tasked to take acquisitions, and depending on the location of the world, we can image an area up to 10 times per day. The power of the data generated by these constellations is enormous. Especially having daily high-resolution imagery of the whole world's landmass is priceless. For example, with this data, we can monitor fields and crops every day. This allows not only a commodity trader to make informed decisions, benefiting, of course, from enhanced market transparency that is offered by the data, but also provides farmers with insights that can help increase their crop yield. And this is a great example, because in the context of this presentation where we're looking at climate change, the agricultural sector is not only crucial for every country and for agricultural development as a powerful tool for economic prosperity, but also it's a sector that is at risk globally from climate change. Climate change can cut crop yields, especially in the world's most food insecure regions, and daily imagery can equip farmers with tools to respond to this. Similarly, planet data can help obtain situational awareness. For example, it can support the assessment by nonprofits of battlefields. And in general, and in a general context, it can shed light on areas that were dark before, increasing transparency globally. With its daily scan, Planet has enabled a paradigm shift for Earth observation data. Rather than telling the satellites where to look, we can scan the entire world every day and make the data uniform, harmonized, and ready for analysis by artificial intelligence without human intervention. Being able to image the whole landmass of the Earth every day and then applying a machine learning algorithm to this data can allow you, for example, to identify a road, as you can see in this image. And this is an early indication of deforestation. This enables action to be taken at the very beginning of deforestation or forest degradation, before we lose more forests. On the screen, you can see some of the facts that drive why we're doing this. As I said, we can help farmers improve their productivity and crop yields. We can help finance improve and measure their ESG targets. We can help manufacturers track their supply chains. And we can help support forest management and governments to track illegal deforestation. In a nutshell, if we want to understand how planetary data and artificial intelligence are changing human decision-making, the quick thesis is not just that we are now aware of action after the event, but rather that today, information is being provided frequently enough to take action in real time. And soon, we'll take this one step further and enable precise predictions about the future by enhancing daily global imagery with artificial intelligence. And once this is realized, the value of this capacity will be immense for decision makers across all sectors, industries, and countries. Earth observation data is relevant for the two biggest transformations of our time. And both the Sentinels and Planet data are at the center of these major transformations, which represent multi-trillion-dollar global economic shifts. First, the digital transformation is sweeping across all industry verticals, affecting everything from agriculture and transportation to forestry and government. This transformation is creating a need for data at real massive scales. Secondly, the sustainability transition is turning economies green. This transformation is being driven by the fact that the Earth is changing more quickly than ever, and in ways that are dramatically disrupting economies, society, and the environment. And agents globally are now all in this transition. For example, the European Commission is committing 25% of its budget to the sustainability transition. Countries or companies have never been more focused on sustainability, measuring their impact and confirming regulatory compliance. Governments want to meet their emission targets. Companies want to measure their ESG targets, supply chains, and banks want to certify green bonds. The list really goes on until infinity. With both of these shifts, the first step is measurement, because you can't manage what you don't measure, which is why access to our data is critical to supporting governments and companies as they navigate these economic shifts. This is also what makes our data relevant to every company in every industry and every government in every country. Specifically on the sustainability transition, Planet can help drive sustainability in three main ways. Firstly, measuring and monitoring of social and ecological change. Planet's data is an essential tool for illuminating ecosystem health, climate impacts, and biodiversity in contexts such as forests, watersheds, and coral reefs. We can also enable efficient operations. Our data can help asset holders to do more with less. For example, help deliver ecologically efficient agriculture, make sure that fewer trees are lost to invasive pests. By improving transparency and reporting, our data can power trusted indicators of sustainability and climate-related performance for industry, for regulators, and for financial reporting systems. And if we want to focus on how Earth observation data can help with some of the toughest challenges the world faces today, we must recognize the role of EO in achieving the Sustainable Development Goals. As you know, back in 2015, the UN established 17 SDGs, which were intended to be a blueprint to achieve a better and more sustainable future for all. Obviously, meeting these goals by their target date, which is 2030, will require significant collaboration and commitment from governments and agents around the world, as well as an abundance of resources. Amongst them, a wealth of data sources are needed as the foundation of informed decisions that drive progress towards defined targets. Objective data must form the basis of efficient monitoring, reporting, and verification systems. Earth observation data is an indispensable tool in this context. For example, high-frequency and high-resolution satellite imagery allows governments to identify risks, to tailor policy responses, to foster efficient resource allocation, and to enable progress monitoring and trend identification. According to the UN Environmental Programme, only 42% of SDG indicators had sufficient data to assess progress made in achieving the SDG targets. At the same time, it has been assessed that 14 out of the 17 SDGs can be assisted by Earth observation. As I've emphasized from the beginning, the power of the data which is already available today is immense. However, a lot of this potential is underutilized. While some consequences of climate change are irreversible, data gaps and analytic deficits can still be addressed. At Planet, we are committed in making our data available and accessible to efforts aligned with these goals, and we strongly believe that the picture of global change that our satellites and other sensors paint will help us deliver the SDGs more efficiently. Earth observation helps us make the invisible visible and fill in critical gaps in our understanding of our changing dynamic planet. Okay, so how can we make sure that we utilize this potential to the maximum? What we're trying to avoid is precisely what Rebecca Moore, a director of Google Earth Engine, tweeted was at COP26. Against ever-increasing but unexploited capabilities of Earth observation, we don't want to be writing the obituary of our planet in high resolution. And this cannot be more true for Europe, where we're definitely not fully tapping into the possibilities offered by space-based technologies. And today I'm going to show you how, in order to exploit the extraordinary potential of space-based technologies, the public sector needs to team up with new space and commercial providers. We have had great experiences of this type of collaboration at Planet, and it is part of an important call to action for Europe. We need to more strongly embrace the commercialization of space, which is already taking place worldwide. and which can really help serve public and societal needs very effectively. In the context of climate change, this is even more important. We're looking at global problems where action is needed now. The magnitude of the problem means that an effective response cannot come from the public sector alone, nor by one individual country or company. We need to bring together actors with aligned missions from all the corners of society and all the corners of the planet. I'm going to share an example in which Planet and the public sector have teamed up to really leverage the full potential of Earth observation. NICFI, Norway's International Climate and Forest Initiative, is a pioneering project funded by the Norwegian government that uses Earth observation data to protect the world's tropical forests. One of the driving principles behind the project is that the best starting point to add 1 billion trees to the tropics is to stop taking down the ones that are already there. This work started in September 2020, when the Norwegian Ministry of Climate and Environment awarded a data provision contract to Kongsberg Satellite Services, KSAT, in partnership with Planet and Airbus. Since then, and as part of this consortium, we have been providing comprehensive access to high-resolution satellite monitoring of the tropics to help reduce tropical deforestation and combat climate change. Planet is providing NICFI with monthly base maps of the global tropics. The data is provided and covers 64 countries and is offered as a public good to governments, decision makers, NGOs, and researchers. This allows the adoption of high spatial and temporal resolution data in national forest monitoring systems, and is bringing unprecedented data and transparency to global climate and conservation efforts. The provision of high-resolution planet imagery is key in this project because it enables tracking forest degradation. Forest degradation is one of the main causes of deforestation. This is the loss at the individual tree level. In order to monitor, respond, and prevent degradation, you need information at the canopy level. Planet, together with our partners, is providing this data to the NICFI program. The coverage, in terms of frequency and level of resolution that our data provides in the tropics, is a perfect example of the point that I've been making. We have the data to act now, but we need to focus our efforts on ensuring that this valuable data is being exploited to its full potential. The NICFI program is doing just this, enabling the use of Earth observation data already available to fight deforestation. The NICFI initiative is also pioneering as a partnership concept, and I want to put a special emphasis on this. It's a public-private partnership where commercial data sets get put out as a public good, although the data was originally in public hands. This is a very interesting business model for new space, a sector which is just taking off and which is trying to find its business model. New space companies like Planet are creating an enormous wealth of data. But unlike public missions like Copernicus, which are of course being centrally funded by governments, these missions are being funded commercially. However, the use cases for new space data are not only commercial. They also have great humanitarian, non-profit uses, and NICFI program really demonstrates this. Certainly, as I have shown today, they have enormous value in the fight against climate change. With the NICFI program, Norway ensures that the data is accessible to relevant forestry ministries, and at the same time enables a commercial business case to be had. It's essential to ensure that the commercial viability of new space companies like ours, so that we can put up even better satellites that will enable us to do even more monitoring. And this is a quick snapshot of some of our imagery in the Amazon basin, which shows how we're tracking deforestation over a period of 3 years. This is the type of data that underpins the work to help prevent Amazon deforestation and support enforcement. This type of data is helping users, for example, in Brazil, report an almost 10-fold increase in action against illegal deforestation. The NICFI program is having excellent results, which once more have been enabled by Norway's vision to ensure the data gets to the right users. In the first year, we now have 9,000 users. And most importantly, action is happening on the ground to stop and fight deforestation. This is not an isolated example. We're working with many partners globally to support more informed, effective, and timely decision-making in the fight against global climate change. The takeaway here is that we're building a deep archive of activity on the Earth's surface, and we're moving from just being able to observe and react to being able to measure and act in real time. For example, being able to intervene in deforestation while it's happening, being able to detect global methane and carbon dioxide emissions as they take place, or monitoring in real time the health of the world's coral reefs. We have the data and tools in place to make a difference today. We just need to make sure that we're using them to take action. Looking to the future, the promise of this big data set combined with machine learning or artificial intelligence is that it will enable predictions to be made. And being able to forecast or predict the future will further improve our efficiency and decision-making across all sectors. This concludes my presentation today. Thank you very much for joining, and I any contact via email. You can find my email address on the slide, which is irene@planet.com. Thank you.
Thank you, Irene. Thank you very much. And thanks for the presentation of the activities of Planet. Absolutely very interesting. Irene mentioned sustainability. This is one of the topics of this decade and most likely of the next decades. And it is also a topic included in the next talk too. Now we move from San Francisco to Adelaide, Australia, crossing the Pacific Ocean in few seconds to meet Mr. Michael Davis, chair of the Andy Thomas Space Foundation in Australia. Thank you, Michael, to be here with us in late evening, and who will now introduce the foundation and describe some Australian school projects funded by the foundation itself, involving space technologies, sustainability, and climate. Thank you very much again, Mr. Michael Davis. The floor is yours.
Thank you very much. It's a great pleasure to join you this evening, and greetings to all of our friends in Europe and the rest of the world. I'll just share my screen. So I hope you can see the first slide. The Andy Thomas Space Foundation is a new entity in Australia. The background to our
sorry, Mr. Davis, we do not see the share. You need to manually do that in the lower bar of your screen after sharing the files.
Thank you. I'm clicking the share button, but nothing is happening.
You should be able to select share screen.
Yes, I did that.
Okay, and then you can have a selection of the windows you can select from.
Okay.
Okay, I got it. Nice.
You have it now?
Yeah, you can hide the notification and go on your presentation.
Okay. Do I need to start the slideshow?
Yeah,
or just
please try.
Keep talking?
Yeah, please try here.
Okay.
Okay, perfect.
Good. Oh, apologies for that. As I was saying, the background to our establishment as a foundation in Australia was firstly the creation of the Australian Space Agency in 2018, and it has main responsibility for developing our commercial space industry in Australia. Secondly, the establishment of the SmartSat Cooperative Research Centre, which has primary responsibility for research and development in Australia, particularly in relation to satellite technologies. And following that, 18 months ago in 2020, our foundation was established to support outreach and education in the space sector in Australia. We have charity status because we are clearly not-for-profit. We are governed by a board of directors. we're funded by grants, donations, and corporate fundraising. And Australian taxpayers receive a tax deduction for any donations they make. Our founding patrons are Dr. Andy Thomas, the Australian-born and educated former NASA astronaut and veteran of 4 space missions. And our other patron is Dr. Megan Clark, who was the founding head of the Australian Space Agency. The 3 pillars of which underscore our activity are firstly that we are committed to advancing space education, which starts at the youngest students in schools and works its way up through all levels of education to post-PhDs. And in our first year, we were able to fund scholarships and research activities at all of those levels in Australia. We also support the Australian Space Discovery Centre, which is a wonderful new museum dedicated to space, located in the same building as the headquarters of the Australian Space Agency in Adelaide. And if any of you have the opportunity of coming back to Adelaide, please get in touch with us, and we'd be delighted to arrange for you to visit the Discovery Centre. Our second pillar is raising space awareness through community outreach, and of course encouraging a new generation of space leaders. And our third pillar is contributing to the national space community through innovation, which includes conducting the Australian Space Forum that some of you will have attended virtually, which is held every 6 months. And it is the leading national space conference each year. And of course, supporting other initiatives similar to that. So as I mentioned, in our first year, we managed to successfully launch and complete 7 different scholarships and award programs, ranging from a program for children in primary schools, and then another program which I'll speak more of for children in middle and secondary schools called the Schools Challenge, a program for undergraduates, a program for graduates, and a special program dedicated to the ISSUP Southern Hemisphere Space Studies program, which we've held every year in Adelaide for the last 11 years. But today I'd like to talk to you in particular about the program we conducted for middle and secondary school students, that is, students of the age of about 12, 13 and 14, which required them to, and their teachers, to initiate projects which address some or all of the 17 United Nations Sustainable Development Goals, which were touched on in the previous presentation from our colleague from Planet. And so I'd like to draw your attention to 4 of the school projects that were presented to us. There were 9 schools chosen for the first round of this program, and 4 of the projects touched specifically on the topics of sustainability and climate, and therefore I thought it would be interesting very quickly to explain a little bit about these 4 projects. The first one was from a school called Vernile East College, and their project involved using satellite imagery to identify farming land, weather conditions, rainfall, surface temperature and climate predictions. Secondly, to use technology implemented on the International Space Station to recycle water. And thirdly, to look at the use of low Earth orbiting satellites to obtain broad trends in soil moisture, involving the use of sensors to detect water in the areas of need. And this school is located not in the city, but on the outskirts of Adelaide and close to a number of farms. And a particular area of a farming area of 2 million hectares of wheat was chosen as the study site. So that was the first example. The second example was St. Paul's College, and they decided to conduct their project by joining forces and collaborating with a village in Indonesia to identify issues, opportunities, and resources on the island in Indonesia where their collaborating high school was located. And the solution that this group of students came up with involved finding a range of food plants that grow well in the Indonesian village and designing a vertical garden. And you might be able to see a photograph of one of the students next to the vertical garden that the school class actually designed and built. And then from that, they looked at developing a nutrient solution that can be made easily with easily obtainable components. And then they created an instruction video that was able to be translated into the Indonesian dialect of their collaborating school. And that I found to be most interesting. The third project was from a rural high school, Yorktown Area School, and they focused on improving education, awareness raising, and institutional capacity on climate change mitigation. And this involved them doing intensive research and study on the mechanism that involves greenhouse gases elevating the global climate. And they also looked at the impact of farming, especially livestock numbers, and also the impact of mining and burning fossil fuels in this process. And the final project was from a school in the metropolitan area of Adelaide, and they concentrated on using hydroponic systems for the growing of edible produce, taking into account the needs of long-term and long-duration human missions to the moon and beyond that to Mars. And they say that the idea was inspired by the movie The Martian, which the students watched to analyze STEM aspects presented as supporting survival on Mars. So I hope our audience found that interesting. I was personally very impressed by the level of sophistication of the scientific understanding of these 12, 13 and 14-year-olds. We brought them together to present, and they had the opportunity of hearing each other's projects. And we received very positive feedback and some expressions of interest along the lines of, I had no idea that this is what working in space and the space sector involves. And so I hope that we've done a small bit to inspire some bright young students to think about careers in our space sector. So thank you for your attention.
Thank you, Mr. Davis, and thank you to be with us today in a late evening. And in particular, I would like to thank you for sharing these relevant initiatives ongoing in Australia, and especially the ones devoted to the new generations, that actually we will continue to fight the climate change. Again, thank you so much, Michael Davis. Thank you. And I will move to the next speaker, going back to Europe to meet Mr. Andy Court, principal at Dutch research organization TNO in the Department of Space and Scientific Instrumentation. Good morning, Andy. For more than 20 years, he has been involved in atmospheric Earth observation missions. The talk today will explain the role of TNO as a research technology organization and the evolution of optical instruments from institutional to new space and their role in the future for worldwide monitoring of the atmosphere. Thank you so much again, Andy, and the floor is yours.
Thank you. I hope everybody can hear me, and I'd like to just say thank you and welcome to everybody. TNO. So what I have here, I don't know if it probably isn't playing, but there's a GIF here. I need to hide. I was told I could hide this. Can't see here to do that. So I apologize, it's saying Andy Court down the bottom there. I can't quite see how to change that. Okay, so this on this opening slide. So TNO contributes to climate monitoring. What you see on the screen here is a map of the world. It's actually a GIF, it should be playing, but it's from 2003 to 2012, measurements of methane across the globe by the SGAC instrument, which was on the ENVISAT platform. Next slide, please. Oh no, here we go. There we go. So TNO, the organization that I work for, it's an RTO, a research technology organization. These are multidisciplinary knowledge organizations dedicated to the development and transfer of science and technology to benefit the economy and society. There are, I would say, hundreds of these types of organizations, not-for-profit organizations across Europe and the rest of the world. And the traditional role for these organizations has been transferring knowledge and technology from TRL 1 and 2 up to TRL 5, so sitting between universities and industry. More recently, due to the gradual reduction of public government funding into these type of organizations, you see that we start to turn to be more commercial in the way that we approach things, particularly for things like technical services. RTOs are also a big generator of spin-off companies. So these are naturally SMEs to start off with. And we also license the IP database that we create. For TNO, we have a mission, which is to connect people and knowledge to create innovations. And the objective of that is to increase the competitiveness of industry and also contribute to society. TNO is made up out of 9 different units, and 2 of those are very involved in space. One is at the bottom left here in the green, is industry. That has the space and scientific instrumentation department within it. And on the right segment, the right red segment up there, circular economy and environment, is where all the downstream activities take place. Now, TNO is a technology and development consultancy. We're independent, not-for-profit organization, founded way back in 1932. And nowadays we have a turnover of around 500 million euros per year for the whole organization and about 3,000 or more than 3,000 employees. About 150 of these work in the space area, and we have a turnover in space of around about 20 million euros per year. So not insignificant, but also quite a key part of the overall organization. So what areas do we work on in space and scientific instrumentation? Well, one of the key areas is Earth observation, but we're also heavily involved in air quality modeling, in our circular economy unit. Also with satellite communication, both laser and radio frequency. Also instruments for ground-based astronomy, instruments for space-based astronomy, scientific instrumentation. For example, in the ITER fusion project, we contribute some diagnostic systems, and also in the manufacturing of high-end optics. We have more than 50 years of heritage of different systems, starting from way back in the early days of ESA or ESRO as it was then, building spectrometers, all the way through to today, where we contribute to the Sentinel-5 mission, for example. So the main areas, I've already sort of highlighted them, but we have a unique position as an RTO, instrument developer in the Netherlands. And our TNO technology is a contributor in major ESA, but also nowadays NASA missions as well. And we have this 50+ years of innovation, moving from idea to realization for scientific space missions. We move from there into also developing small satellite instruments as well, and I'll come back to those much later in the presentation here. And that's moving from the idea, from what the scientists, what the people tell us that they need in terms of specific measurements, as opposed to institutional missions which have a much broader remit, but also with the idea that these small satellite instruments can become industrialized. Information products on the downstream side, so practical information from satellite data by data processing, covered by several of the previous speakers here about how these are applied in everyday life in order to provide information to policymakers, etc. So the Dutch government, in this case, the European Commission, but also other local government agencies. And now to move on to the main part of my presentation, the monitoring of the world's atmosphere. So you say, why space instruments? Well, atmospheric monitoring is a key area, requires state-of-the-art technology and science to achieve the scientific objectives that are requested. One very good example of the way in which space instruments have contributed to our well-being is by monitoring the ozone layer. There was the ozone monitoring instrument, I'll come back to that in a moment, that has spent many years measuring the ozone hole and seeing how the protocols for reducing chlorofluorocarbons has led to changes in the hole. Of course, there are other impacts now taking place. The Earth is a very complex system, as we know, and things like cooling of the upper atmosphere also impacts it, as well as all the chemical interactions from the chlorofluorocarbons that were being emitted much earlier in the last century. Today, the most detailed and accurate daily measurements of air quality worldwide come from the Tropomi instrument, which is also on the Sentinel-5 precursor mission, waiting for the Sentinel-5 mission to eventually be launched. We measure the status and changes of the hole in the ozone layer, both north and south, very important for things like checking health of people, but also crops, which can be very damaged by UV radiation. The TNO position is that we have instruments, we work on instruments for upstream, so we transfer the user needs. The scientists or other users come and present a set of requirements that they need to have in order to be able to measure specific parameters on the ground across the world, so without borders. And that information, we also work on the downstream side to convert that into space data that we can utilize in value-adding applications, much as described by some of the former speakers here, particularly for Copernicus, for example, in the CAMS program to monitor the atmosphere and pollution in many different places. If you look at how instrument capabilities have evolved over time, so we started off many years ago with things like the Global Ozone Monitoring Experiment, the GOME instrument. That was a simple instrument. It was a part of the SGAC roadmap. It replicates some of the channels inside that. And it was later adopted by EUMETSAT as their key instrument for monitoring both ozone, but also the nitrous oxides in the atmosphere as well. And that has been on the METOP platforms from 1996 until 2000. Well, onwards from 2006 up until way beyond where we are now. We have the METOP A, B, and C, or 1, 2, 3. The first one has just been retired. The second and third one are in orbit and will continue doing their jobs for many, many years. What you see here is a time evolution of instruments from GOME to SGAC, which was on the MVSAT platform, the OMI instrument on the NASA EOS Aura platform, TROPOMI, which is the Sentinel-5 precursor mission, a combined development by the Dutch Space Office and ESA, and more lately Sentinel-5, where TNO also contributes to 2 subsystems there, the telescope systems and the UV spectrometer. Now, the thing about all these instruments is that they have got increased specifications as they go through over time. So from 1995 up to 2020 plus. And one of the key parameters there has been how they have changed in terms of spatial resolution. In the early days, the GOME and SGAC, the pixel size that you could measure and get your signal retrieved was about 100 by 100 kilometers, about 10,000 square kilometers. So covering very large regions across the globe. It did indeed, both of them measure the global atmosphere once every day. The OMI instrument reduced this down to about 13 by 13 kilometers, so roughly about 100 kilometers squared. So you were starting to be able to see things within individual cities. And now TROPOMI and later Sentinel-5 reduced this down so that we are measuring at the 10 square kilometer level, which is almost within cities. So you can actually distinguish across cities where things are happening. Each of these instruments, if you look at them from the point of view of spectral range and size, each instrument actually is about the same size, roughly. They're all in the region of about 100 liters up to about 1,000 liters, so about 1 cubic meter. That means that actually what has happened is that the technology has changed. Since 1995 up to now, whole ranges of different things. I hope everybody can hear me. I just had a small message. Oh, you do. Okay, very good. Okay, thank you. Okay. Yes, so each instrument is roughly the same sort of size, but the actual capabilities have increased dramatically. So from 10,000 square kilometers to 10 kilometers squared over a period of about 30 years or 20, 30 years. And Sentinel-5 will be the workhorse. It'll replace the GOME instruments as the workhorse for the foreseeable future up until the mid-2030s. And then we'll come to the next set of instruments. All right, so I mentioned earlier that there is innovation, so small satellites. Utilizing some of the technology, so things like free-form optics, but also improvements in things like detectors, which have increased sensitivity nowadays and capabilities. It's been possible to miniaturize some of those key characteristics of those institutional satellites. Each of those previous satellites, they measure a very wide spectral range, and they measure a wide range of different trace gases inside the atmosphere. But it was realized that actually sometimes you only want to measure some of the different gases inside the atmosphere. This could be nitrous oxides, it could be methane, it could be carbon dioxide. And if you target just those particular gases, you only need a limited range in your spectrum. Using that, you can make much smaller instruments. And the advantage is that they can be much less expensive because you're only targeting one specific product. You can have a constellation of satellites, which gives you much better temporal resolution across the daytime. And they're much faster to produce, so they're faster operationally available. And as I say, relevant applications are things like measurement of sources of greenhouse gases, volatile gases, the ammonias, ammonium, nitrous dioxide, and so on. And this leads to a set of state-of-the-art high-tech instruments, but also services that can back that up. If we consider how this comes together, so in the long term, there will be institutional instruments. The big advantage of those is that they provide independent measurements. We've seen what happens with Copernicus, but also, so we've heard something about what Planet is doing as well, in terms of open data policies. And these are critical to ensure that these type of instruments can provide the information to the people who need it. If you look worldwide over the coverage, you see that there is some ground measurements. Here in the Netherlands, for example, there's about 20 or 30 points inside the country where trace gases are measured at ground level. But that hardly covers the whole of the Netherlands, and the same is true across Europe and across the world. There is a network of measurement sites, but they're very sparse. So the advantage of a satellite is it looks across the whole globe. And you can see in the figures on the right-hand side, the nitrous oxide that's measured by Tropomi, for example. This was in June 2018. You see all the hotspots around the world. And if you zoom in, you can see Europe in the next one down. And then finally across, you see the range of difference between the OMI with its 100 square kilometer pixels, and those are the Tropomians with the 10 by 10, where you suddenly see that you can pick out much more detail about what is happening on the ground. Now that's quite critical for the next phase of the way in which things can operate. So we have these capabilities. The information collected by these institutional satellites, as well as I've mentioned, it stretches over many, many decades. And the advantage of that is that you can now use new analysis capabilities, new computing capabilities to reassess historical data, which does help not only to look back and see how things developed over time, but it also provides a capability for improving the algorithms that are used for future satellites, and so we say speeding up the data rate, the speed at which data can be made available in order to task satellites to do different things. So if you look at local, and this is where people like Planet and so on were mentioning, again, if we go through the same set of criteria, at a local level, you can have independent measurements. There's generally, as I said, there's a very sparse range of measurement systems across countries for making measurements, and many countries where this cannot happen. So you have a lack of reliable and comparable figures for pollution, for example, by individual countries, organizations, and industry. And mostly it's all estimations right now. So what can we do? Well, now there's a paper, for example, it starts to highlight this, and that is nowhere to hide. Satellites look down and they see everything that's underneath them. And what it means is that satellites like Tropomi can recognize that there is an event taking place on the ground, and other satellites can then come in and make more detailed assessments or measurements of where things are happening. So, for example, methane. Now, methane, I don't need to go through all the criteria here. It's one of the most important gases that we have that's creating a greenhouse effect. And there's movements now to create systems whereby Tropomi will measure global methane concentrations, provide the data very quickly, and then other satellites are able to come in and make better measurements of it. So here we have the example of Pennsylvania, where there was a blowout from a site there. It was recognized on Tropomi, and then it's possible to zoom in on it and find out where exactly this is taking place, and then local authorities can then act to make sure that blowout is properly shut off. So combined satellite sensor observations, which will provide a wide range of spatial coverage and resolution. We zoom in on it. You get average methane concentrations. And the methane from open-cast coal mine in Kazakhstan, for example, would then be measured by something like GHGSat, a commercial satellite. But in the future, there's also a proposal from TNO for something called Tango, which is a small satellite instrument which will work in conjunction with the Copernicus CO2M mission, but also the Sentinel-5 mission, for example. And it provides near real-time, high-resolution open-source data on methane that scientists can use for their future estimations. That type of system, together with GHGSat, can be operational now, and ESA is moving towards that. So as a summary, as I come to the end, so over the last 50 years, design and capabilities of optical Earth observation instruments has vastly increased the observation possibilities. You can see that we've gone through roughly 4 generations of different types of instrument, and each time the capabilities increase by an order of magnitude. Institutional systems from EUMETSAT and Copernicus, they provide long-term operational records. They're often multi-purpose instruments, and they have a philosophy of open source data, which is very helpful in providing the base information that's needed by all the policymakers. Now, new space or new space economy players are targeting niche capabilities. These are satellites with high spatial resolutions and small satellites in constellations, not small satellite constellations, small satellites, big constellations. They provide imaging, daily imaging across the planet, but also they can be targeted for emission monitoring to provide information back to policymakers, industry, governments, etc. And this combination of institutional and new space systems, so the Sentinel-5 precursor, the Sentinel-5 CO2, and things like GHGSat and Tango, and I'm sure other future instruments, are going to give unprecedented capabilities to recognize and then identify the emission sources that we need to keep in mind to make sure that the climate targets are going to be met. Okay, and with that, I would say thank you, and thank you for your attention.
Thank you so much, Mr. Court, and thank you to show the TNO contribution for helping the comprehension of the atmosphere and for the new space, and in particular in developing tremendous instruments such as the historical ones GOMI and Schemaci and the recent TROPOMI and Sentinel-5. We aim to monitor the main key features of the atmosphere. Really interesting presentation. Thank you again.
Thank you.
And now we continue to travel across the world. We cross the Atlantic Ocean this time to go to the eastern side of the United States. I have the honor to introduce Dr. Diane Howard, currently serves as a Director of Commercial Space Policy at the United States National Space Council. Vice President Kamala Harris, Chair of the Council, announced the release of the United States Space Priorities Framework last week. And Dr. Howard will speak about some of the ways the Council foresees using space capabilities to address the climate crisis. It is a pleasure to be here. Thank you so much. And it's early morning, and so thank you so much for that. Thank you so much to stay with us. Please, the floor is yours.
Thank you very much, Fabrizia, and thank you to the organizers for inviting me, and also to Roberto for putting everything together and helping me navigate all of this. So good morning from here, and good afternoon or good evening wherever you are. I'm going to give you a little bit of a different perspective. I'm going to speak to you from the United States government perspective and sort of unpack some of what we're doing right now. So in the first year, it's not even quite a year, the Biden-Harris administration has really taken a lot of fundamental action to ensure that our US policies are sound and coordinated. And that we have a strategy so that we don't just have policies, but that we also have a way to go forward and make sure that we do something with these policies. And I'm talking about policies that go back for well over a decade. So as you know, the United States has been very active in articulating policies. And so we're building upon the policy documents and instruments that we have crafted over the past many years. And I'm speaking to a group of people that are here on a virtual webinar or conference about space. So clearly we all know and love space, but we in the US government right now are keenly aware of the fact that it's not just that we speak to each other about space, but that we also bring the message out, because we understand that space capabilities really do underpin so many vital elements of our society, from education and science to also to national security and the thing that I work on most, economic prosperity. But again, these things are all linked up. So to that end, the United States is very pleased to share the United States Space Priorities Framework, which was endorsed and unveiled at last week's National Space Council inaugural meeting for this administration by our Vice President Harris. And this document provides guideposts. It gives us a way to develop, not just develop, but also to implement the national space policies and strategies that are contained within it, because it helps us organize how our civil and our commercial and our national security efforts can work together to deliver and to ensure that the benefits of space are broadly and equitably applied. And that's a little bit what I'm going to talk about today, because the framework reflects where space activities really do advance the broader domestic and foreign policy priorities of the Biden-Harris administration. And one of those is to leverage space-based data collection and assessment and dissemination to address the climate crisis. So there have been recent commitments from both President Biden and Vice President Harris to that end. For instance, at COP26, President Biden committed the United States to support efforts that would deepen global understanding of climate risks and vulnerabilities, and also adaptation solutions. And that these things would be done while we supported expanding the development and innovation from the private sector. We've heard a lot of really super cool stuff today, but also the delivery of those climate information services. And again, the private sector has a big role in that as well. And decision support tools. So not just the data, but what do we do with the data, and early warning systems. That was a commitment, but it doesn't stop there. During her trip to France last month, excuse me one moment, it's a little early for us. I need my coffee. Vice President Harris also committed the United States to join the Space Climate Observatory, excuse me. Now, this is really wonderful because this is a global effort, and this also expands the access to data. So access, I want to talk a little bit about access, because collecting data is only part of it. We need people to have access to the data, and we need them to know and understand how to get to it. And the next part of that is what to do with it. So at our meeting last week, we invited a few new members into the National Space Council, and not as traditional members of the Space Council, and yet we're bringing them in because they do things with space and they do things with space data, and we're all working together. So that's what I want to talk to you a little bit about, some of these collaborations within the US government that we bring to the commitments that the President and Vice President made. So at our meeting last week, the Secretary of the Interior, Secretary Holland, shared about how the United States Geological Survey's Landsat data is being used all over the world as a basis for high quality science. What's interesting about Landsat data is that it's a 50-year record. So it, like the Akashic record, a 50-year record of images of land and water and coastlines. And that data, like all the data we've heard about today, helps us improve our responses to natural hazards and also to weather events. But it doesn't stop there. It's not just information. It's knowing that we can model based on this long temporal timeline, and we can make predictions, and we can take decisions, which help us with things like resource management as well. So space-based observation data from USGS, but also from NASA and NOAA satellites, it's freely available. It's available to the public, available to all. That's a key point. And many are using it. So farmers are using Landsat data. They've developed precision agriculture, which allows farmers to employ climate smart practices. So they grow more using less resources, and they produce less greenhouse gases in the process. Sounds like a win-win to me. So our executive branch agencies are collaborating on a number of initiatives that have positive impact on climate. And I'm going to tell you about a few of them. And what's wonderful about the meeting that we had last week is that all of the we had all the members. Many of them were cabinet level. Well, they're all cabinet level, and then many secretaries and then sometimes their deputies, listening to one another and hearing the things that each other are doing, and realizing that they have other places where they can collaborate, which is exactly what we wanted. So, for instance, the United States Department of Agriculture is working with NASA. And it's working on a number of different projects that deal with water management and crop assessment, some of the things that we've heard some of the speakers immediately before me talk about, carbon storage and remote assessment of plant health. But it doesn't stop there. Then the Federal Emergency Management Agency, FEMA, it's working, and it works often with the Department of Homeland Security to respond to natural disasters and extreme weather events, and they use the geospatial data to monitor, and they predict, and they help prepare the public before things happen. And they deploy resources more timely. But something that I learned was that FEMA also uses that data to map flooding in the United States. And as a result, they can make a much more accurate risk analysis. I thought that was a little more granular and quite interesting. So the access to the data is key. And so is efficient processing of the data. I said, the data, but then we have to take it further. So efficient processing of the data. So we heard a very good example of that from Andy Court in the last presentation about the tasking of satellites. And that is an excellent example of what I'm talking about. But another contributor to some of the ways that the U.S. government is addressing in a whole of government fashion and a response to the climate crisis is that the Department of Energy is contributing in a whole different way. And that is, they have a bunch of fantastic national laboratories that have developed algorithms to help them, FEMA, understand all of that flood-related geospatial data. So that is helping them create not just the risk analysis, but a much more holistic picture of all the changes on Earth and to measure some of those changes. And those different capabilities are some of what we bring to the commitments that President Biden made at COP26 and some of what we intend to work with the Climate Observatory. So I'm gonna give back some time, and I think everybody will thank me for that. But what I want to end on is that the climate crisis does affect all of us here on Spaceship Earth, and I just want to really bring to you that the United States is committed to leveraging our space capabilities and to providing open, equitable access to space-based observations. And we mean that. I mean, we're working with, the Department of Education to make sure that students that don't traditionally know that this data even exists or what to do with it, that they have access. So we're doing that within our country, but that this is not just internal. This is something we all have to deal with because we are going to solve this problem together. But we need the science. We need the support of the science to do so. So I thank you very much for your time and your invitation. And I wish you all a good day.
Thank you. Thank you very much, Dr. Howard. It was a real pleasure to have you here with us today. And thank you for bringing your message, for sharing the US space priorities to implement space policies. And thank you for highlighting the importance to deliver the climate services and the role of the private sectors that is becoming more and more important in these days. So now we continue our travel and we go to the tropics to meet Mr. Adnan Rais in the United Arab Emirates. And Mr. Rais, good morning. It's a pleasure to have you here. Mr. Rais is Senior Director of Remote Sensing Department, Program Manager of Mars 2117. He will present a talk about climate change, highlighting briefly the causes and consequences, strategies to encounter it, focusing on the United Arab Emirates efforts and initiatives. He will also talk about the first Emirate environmental satellite, the EGEOS-1, to monitor greenhouse gases and air pollutants. So thank you again, and the floor is yours.
Thank you very much for the introduction. Good morning and good afternoon, everyone. It's my great pleasure to be here today to talk about this very important topic, to highlight the global topics that attracts, broad international attention. The climate change, its severe impacts on our Earth, and my talk today is basically will highlight the causes, the consequences of this issue, in order to recommend some effective collaborative strategies to mitigate the serious danger. And at the end of my talk, I will talk about the UAE's effort in encountering this issue and some of the space initiatives that we have in the country. As you know, the climate change is one of the most complex issues facing us today. It involves many dimensions, covering science, economics, society, politics, as well as moral and ethical matters. This issue culminates as a global problem felt on local and international scales, continuing to be around for decades and centuries to come. So let's think profoundly about how much climate change do we have. This will definitely determined basically by how our emissions continue and exactly how our climate system responds to those emissions. Despite the increasing awareness of climate change, our emissions of greenhouse gases continue on an alarming rise. In 2013, the daily level of carbon dioxide in the atmosphere exceeded 400 parts per million for the first time in human history. Now, we got the core question, how can we mitigate climate change? And the answer is basically reducing the flow of heat-trapping greenhouse gases into the atmosphere, either by reducing sources of these gases, for example, the burning of the fossil fuels for electricity, heat, or transport, or enhancing the means that accumulate and store these gases, such as oceans, forests, and oils. The successful implementation of these steps will lead to avoid significant human interference with the climate system and stabilize greenhouse gas levels in timeframes sufficient to allow ecosystem to adapt naturally to climate change, ensure that food production is not threatened, and also to enable economic development to proceed in a sustainable manner. In addition, mitigation strategies can include adapting buildings to make them more energy efficient, adopting renewable energy sources like solar, wind, along with helping cities to develop more sustainable transport, such as rapid transit, electric vehicles, and biofuels, as well as promoting more sustainable uses of land and forests. Now, let me highlight the three potential strategies for mitigating the climate change. Initially, conventional mitigation efforts employ decarbonization technologies and technologies that reduce CO2 emissions, such as renewable energy, fuel switching, efficiency gains, nuclear power, and carbon capture, storage, and utilization. Most of these technologies are well established and carry an acceptable level of managed risk. A second round consists of a new set of technologies and methods that have been recently proposed. These techniques are potentially deployed to capture and reduce CO2 in the atmosphere and are termed negative emissions technologies.
Sorry to interrupt, Mr. Rais. We are not seeing the presentation moving on. We are stuck on the first slide.
Yes, yeah. I'll be moving on to the next slide.
Okay, perfect. We thought we were stuck in the first slide. My bad. Keep moving.
No problem. So basically, in terms of in terms of the third route to revolves around the principle of alerting Earth's radiation balance through the management of solar and Earth radiation. It's also worth mentioning that the UAE government has set and implemented several strategies to counter the climate change. The UAE is the Gulf country to start on the new energy strategy, which involves the nuclear power and solar energy, in addition to natural gas, which covers majority of the UAE's needs. The UAE's largest emirate, Abu Dhabi, and the capital, has committed to more than $15 billion to renewable energy programs through the Master Initiative, which undercovers twin commitment to the global environment and the UAE's economy diversity. It also focuses on the development and commercialization of technologies, renewable energy, energy efficiency, carbon management, water usage, and desalination. And several months ago, in the UAE, we launched our first environmental satellite. It's called the DMSat-1. It's a nano satellite, which is said to be the city's partner to fight the climate change. Using the state-of-art space technologies, DMSat will monitor, collect, analyze environmental data, as well as measure air pollutants and greenhouse gases. It will also help create maps of the concentration distribution of greenhouse gases in the country and study the seasonal changes. Prior to DMSat-1, we used to definitely use satellite data from available sensors in orbit, in addition to the ground measurements. However, as a country, we did not have our own dedicated mission to study the greenhouse gases, monitoring them, and monitoring the air pollutant. In collaboration with the municipality, the Dubai municipality, they approached us in the Space Center, asking us for including a space solution, and correlate the data from that space solution with the data gathered from their ground stations, in order to have this global coverage and study and monitoring of the greenhouse gases and air pollutants in general. And also, as part of the Paris Agreement, each country has to create its own inventory to monitor of the greenhouse gases, talking about the CO2 and the CH4 level, and working together with the international community to add different sources and different technologies and systems in order to monitor the air pollutants in general. So accordingly, we worked with the University of Trento, the Spaceflight Lab, on the development of DMSat-1. The university developed the mission, and we at Mohammed bin Rashid Space Center worked on the downstreams in terms of the development of the value-added products and the final applications that are shared with the municipality as well as with different partners. So DMSat is a high-performance small satellite. Its total weight around 16 kilogram, launched last March from Baikonur launch site. On DMSat, we have three main instruments, as you can see in this slide. The instruments, basically the polarimeter and two spectrometers. We have a fixed solar panel and the two cameras here representing the polarimeters, as well as the spectrometers in the top bottom of the mission. In terms of the concept of the operation of the DMSat-1 mission, especially for the polarimeter, it takes images at different angles, 3 to 7 angles maximum, and those different observations for the same target is taken through a single pass. And there is a 30 seconds basically gap between those different observations, and the images taken at 0 and 90 polarization. For the polarimeter, we have the red, blue, and the near-infrared bands. At the same time, we have the two spectrometers that are also taking and collecting the data at nadir. In terms of the primary instrument, the polarimeter, as mentioned earlier, is this a multispectral with dual polarization, We have those spectral bands, the blue, red, and the near infrared. And with a single image, we are covering an area between around 107 to by 38 kilometer. And the spatial resolution of our polarimeter is around 40 meter. And the altitude of the satellite, it was launched at 550 kilometer. And the main, basically, application of the polarimeter is to monitor the PM 2.5 and PM 10. And I have to mention also that this is like the first time that we have such a mission that basically focusing using the polarimeter technology on such a small mission. So it's a unique data set that we're working with the international community also to better understand the advantages of this technology and sharing the lessons learned with other future missions. Here we have the list of the data products generated by the polarimeter and the different levels. As you can see, from the level 0 all the way to the level 2, which we are generating the aerosol optical, the effective radius, and the concentration of the PM 2.5 and PM 10. Here we have some sample of the images and data taken by the polarimeter over UAE, and we're on a regular basis taking data over the country and sharing that with our environmental agencies and municipalities. The secondary instruments we have, as I mentioned earlier, we have 2 spectrometers. We have the Argus 1000 spectrometers, and those are the spectral range for the 2 spectrometers. And basically the focus of those spectrometers on the greenhouse gases, the CO2, CH4, and the concentration of the H2O. And here we can see that the different types and different levels of products generated by those spectrometers, which are the commercial off-the-shelf products, that we managed to include them into this small mission so that we have a global and full understanding or better understanding on the climate change in general, as well as the air pollutants and the PM 2.5 and PM 10, as well as GHG gases concentration over our area of interest. And here we have some of the initial findings and the data generated and from the 2 spectrometers that we have on DMSAT-1. The DMSAT-1 is fully operated through our ground station here at Mohammed Barraj Space Center in Dubai, where we have the direct contacts and communication and all the tasking done here through our station. And we have also a dedicated team working on processing the data generated and also collaborating very closely with the universities and scientists to better understand those data sets. So here we have also some sample of the images and the data collected by the spectrometers over UAE. And as mentioned earlier, the spectrometers data taken at nadir pointing. So this was a quick presentation about our efforts when it comes to the climate change and the different initiatives that we have in the UAE in order to encounter and overcome the climate change issues. Thank you very much all for listening.
Thank you, Mr. Rais. Very interesting. Your initiatives are absolutely interesting, and congratulations for the development of this first Emirate environmental satellite. I think it's a milestone for you, and so very congratulations. And I would like to thank all the speakers of this session, of the climate session, for having presented the different phases that we need for understanding the climate. And we have seen what Europe is doing with the ESA and European Union programs. We have seen the important role of the carbon dioxide, and also what the private sector is doing. And probably this is one of the most important argument that are on the table of of the main space agency and institutions. And also, we had the opportunity to receive messages from US, Australia, United Arab Emirates, and there are challenges to face in the next years, clearly. Among the others, as mentioned also by Professor Battiston, there is the need to have a common and shared policy to fight the climate change. So with this, I would like to conclude the session. Also, I would like to remind you that in the afternoon, there is the asset protection session chaired by Cristina Valente of Telespazio. And the session will start at 3 o'clock sharp. So I invite you to stay tuned on the New Space Economy ExpoForum. And I would like to thank all the participants. Thank you so much for that, and see you the next time.
Hello. Good afternoon, ladies and gentlemen. I am very pleased to open the panel Asset Protection. I would like to introduce myself. I am Cristina Valente, Head of Institutional Key Account Management in Telespazio in Marketing and Sales Department. I will be moderating this panel that is composed by Mr. Rolf Densing, is the Director of Operation of ESA. Ambassador Sorin Ducaru is the Director of European Union Satellite Center. Mrs. Aertiola, she is a Secretary General of the ISOA. Mr. Stefano Ianniti, Head of Security of European Union Space Program Agency. Mr. Jakob Gier, Head of Space Surveillance and Tracking of UK Space Agency. And Mr. Ignazio Dogliani, CEO of CIPAL. Mr. Juan Tomás Hernani, CEO of Satlantis. Mr. Mirko Ermini is work for RFI, the Italian Railway Network. And Mr. Maurizio Cheli is an astronaut. I would like just to give you a short introduction, just to forgive the context of the topic. Asset protection is the third accelerator that the high-level advisor group has identified to stimulate the use of space-based applications and services in Europe. We refer here, in particular, to the space debris, which represents a constant threat to the space assets, and to the space weather, mainly due to the action of the sun, which may represent a risk not only for the space assets, but also for the ground infrastructure, that eventually may impair the availability of critical services such as GNSS, SATCOM, etc. In this context, it is important for Europe to rely on autonomous systems to address such challenges, in particular identifying and tracking the debris and allowing the reduction of false collision alerts, and protecting assets in space. The discussion at the European level is oriented to develop our capability to observe, forecast, removing debris, and provide in-orbit servicing. Europe needs to prevent damaging and disrupting its economically vital space and the ground infrastructure. This explains the great utility and the interest of such subject, traditional in the dimension from space to Earth, aiming at the protection of critical infrastructure through remote sensing services. And today, in the new definition of a European regulatory framework, is also on its way, which will be the result of harmonization and will strengthen the economic chain to protecting critical assets. During the discussion, we will look all these different aspects thanks to the contribution of such distinguished and diverse actors from industry, institution, and science. Europe will play a leading role in the future evolution of this space market. The expectation that 2022 and the subsequent years may witness a quantum leap in European ambition and capabilities, starting with the next council at the ministerial level and the programs that will be part of it. Okay, now we can start, and I'm really pleased to introduce Mr. Rolf Dessing. He's the Director of Operation of ESA and also is the Head of European Space Operations Center in Darmstadt. Please, Federico, we can start with the video.
Good afternoon, everybody, and thank you for inviting me to this important session on assets protection. And from what I see from the conference agenda, this is also about Green Deal and global warming. And this is why I have decided and asked your understanding to submit a video and not increase my CO2 footprint by traveling to Italy. So as I say, thank you very much for inviting me. As a matter of fact, it was Roberto Battiston, who is also a prominent participant and contributor to this conference. He's the one who invited me, and thank you very much, Roberto. Now, to give you a bit of context, most of you may know that ESA Director General Josef Aschbacher, who also contributed to this conference, put an Agenda 2025 on the table on the first day when he took office, which was in March 2021 this year. And part of this agenda was the ambition to lift space to a new level, meaning beyond the level of ministers to the level of heads of state. And this is why we will be having in February, mid-February 2022, next year, a so-called Space Summit under presidency of French President Macron, hopefully with many heads of states participating and discussing space issues. And in order to arrive at a meaningful agenda, our Director General invited high-level personalities to help shape the agenda and the ESA contributions to such agenda. And so here you see a picture of the group of personalities. We see former Director General of ESA, Jean-Jacques Dordain, who I saw as also speaker at this conference. We see Roberto Battiston right here. We see Rafal. I also saw on the agenda CEO of ISSUP. Many other famous and legendary figures, and they helped us very much to select meaningful subjects that we can bring to the agenda of heads of states in February next year. And so we arrived at three, what we then called accelerators, namely space for a green future, rapid and resilient crisis response, and protection of our assets in space. And then we ask heads of state to decide on those proposals that ESA is putting forward. So, and to decide and to accelerate is the idea. Because we believe that space is underutilized, we can do more for our society and economy by duly using our capabilities, our expertise that we have in space, in ESA, and of course beyond ESA in Europe. Now I was invited to this conference to elaborate on protection of space assets, which I'm happy to do. So our space environment is rapidly changing these days, and this is because we have ever more satellites in space. Is the arrival of mega constellations. The number of objects, particular number of subjects, is steeply increasing. Here we look at a model of objects greater than 1 meter, for example, satellites. And there, I guess, we have around 7,000 satellites flying in space these days. If you look a bit closer, objects greater than 10 centimeters, we have about 30,000 of those. This is about what US assets can resolve. This is satellites and fragments that we see, and the smaller we go in the model, looking at objects smaller than 1 centimeters and objects smaller than 1 millimeter, we have millions and millions of pieces flying around, actually, that could destroy our spacecraft. And it's not that we have never had an encounter with pieces like this. Here we see a hit of about a 6 millimeter piece into a panel of the Sentinel-1 satellite. This is one of the few satellites which has a selfie camera on board. And actually you can take pictures before and after, and you see the crater. And this hit by a piece of space debris then released a couple more pieces that are now flying in the orbits around us, also as space debris. And by the way, the satellite perfectly works. It has a degradation in power of about 10%. So, looking at the increase of satellites, what we see here is the timeline on the bottom, going to the right, and the number of satellites in the vertical scale. Sputnik was launched in 1957, first satellite, and we see that the number of satellites is rapidly increasing. And a major contributor to this is the Starlink constellation, of course. And of the 3,500 operational satellites that are today in space, about half is owned by one person, by one company, by Elon Musk and SpaceX. And they are having certainly a very good business case. But we have to cope with this situation. And to look at the general societal and economic field, today we have about 14 million jobs in Europe that are affected by space systems, and up to 1 million European jobs would be lost in the event of loss of all space systems, accounting for 6% of the European gross domestic product. And so there is a price to pay if we don't act. And so we are relying on space infrastructures day by day, on Galileo, on Copernicus, on weather satellites, on communication satellites that we need, for example, to keep our stock exchanges going. Jean-Jacques Dordain once said, if we switch off the space segment for 1 day, we know what the value of the space segment is. And so we cannot afford losing the space segment, and hence we need to protect it. So unfortunately, we in Europe do not have an end-to-end picture of the rapidly changing space environment. We are to 100% dependent on the picture and collision warnings that we get from our US friends. And here I should correct, probably not 100%, probably 90% dependent. And this is threatening European freedom of action, meaning we cannot end-to-end intelligently decide in which orbits best to fly, because we have no clarity on what is going on in the orbits around us. And this is also impacting the competitiveness of the European space sector. So what I'm lobbying for is for Europe to protect freedom of action and the competitiveness of the European space sector by creating appropriate infrastructure that would bring us on equal footing with our international partners in assessing the space environment. And I know that there are many people doing actually a very good job, and we do have lots of expertise around in member states and also in the EU. And so they're doing fantastic stuff. Let me just, I'm speaking for ESA here, and let me just elaborate on what I could bring to the table, actually what ESA could bring to the table. ESA, and in particular we at the European Space Operations Center, are operating satellites in space since way more than 50 years. We have a world-renowned space debris office, so I believe we do have some technical expertise in this area, and we are also very experienced in setting up large-scale European infrastructure. So not speaking for selfish purposes, speaking really for protecting European freedom of action and the competitiveness of the European space sector, I believe we need to join forces in Europe beyond national interests and to lift the solution of these shortcomings to a European level where each stakeholder contributes expertise and accelerates toward a solution. And actually, what are we doing in ESA? You may have heard from our Director General, who was part of the opening ceremony, is what I read in the agenda, that he is pursuing a zero debris policy, meaning that at least for ESA satellites, what we want to do is what we launch in space, we bring back. And so I guess the most straightforward way is to equipping our satellites with return engines and make them fail-safe and redundant. And so after ceasing operations of a spacecraft, we actually bring it back to Earth. And if we fly in very low Earth orbit, one could also consider track fragmentation devices to do so. But we want to go a step further. We want to develop technologies to automate collision avoidance. And actually, I myself, I'm running the European Space Operations Center, so we are operating the ESA fleet of satellites. And we have probably flown more collision avoidance maneuver than anybody else in Europe, I suppose. I didn't count them over the last 50 years. But I can tell you, we have on a daily basis around 1,000 or more collision warnings that we are getting in. And we cannot cope with this manually anymore. We need to automate. And this is why we are working with experts on machine learning and artificial intelligence to do things way more operated in the future than we have done in the past. And we are also looking at laser-based momentum transfer, actually by demonstrating to move smaller pieces of space debris with light pressure being injected by a laser beam. But we are doing more. We are also actively deorbiting debris. For example, with this, what we call Clear Space One mission. Why Clear Space One? This is a very impressive Swiss startup. And actually, we will be lucky enough to have the CEO, Luc Penier, later today, reporting on this. And those are also ways and means to bring back space debris. And this is the first ever active debris removal mission that we have actually bought end-to-end from ClearSpace. But we do not want to stop at active debris removal. We can go one step further by transitioning to a circular economy in space. And this is why we will be proposing beyond active debris removal, also in-orbit servicing at the next ESA ministerial conference, an ADR plus iOS makes for Atrios, which is the name of our program. So one could imagine tankers in space to refuel spacecraft that are otherwise still that take over certain functions of a spacecraft, that do repair of spacecraft in orbit, that do repositioning of whatever. So what I have depicted here is a vision for the year 2050. We probably will not be there in one go. So we start with a proposal to ministers and next year. But if we are serious about protecting our assets in space, it's not only about space debris, it's also about space weather. And the sun actually can have to our assets in space and also to critical infrastructures on the ground. The sun does what it has to do. We have no influence on this, but by only predicting what is coming at us, say by what can be imagined as a space weather forecast, we can do a lot of protection. For example, turning away sensitive sensors of spacecraft from the direct line of sight to the sun. So what we are currently doing is preparing a mission to fly to Lagrange point 5 and doing this jointly together with the US partners who are flying to L1. And we would afterwards share the data, which is a very valuable package of data that we are getting. It's very powerful in predicting space weather. So what happens, the sun has a cycle of about 11 years. Next solar high will be in the year 2025. And the sun is cooking, almost like a pot of hot stew. And every now and then it throws out massive solar mass ejection, is what it calls. This can be billions of tons of ionized material. And if it hits on Earth, it can deform the Earth's gravity field and also the Earth's magnetic field, I meant to say. And this will distort navigation signals. This can overload power grids on the ground. This can destroy our radio communication. So it can have huge effects. And stuff like this happens, even though it may happen very, very rarely. But I guess we are living in a time of crisis, with the pandemic going on, with climate crisis, with terror and military confrontations. Humanitarian crisis. So whenever you switch on the news, there's crisis over crisis. And the least we need is a crisis, yet another crisis in times of crisis. And therefore, I believe it's important to protect our assets and also our astronauts, I must say, in the context of space weather, because astronauts are particularly vulnerable if they are outside of the shielding of a spacecraft. Say, for example, on planetary surface operations or on extravehicular activities. So this is the last chapter of Protect, is ensuring safety of our space and ground assets and protecting astronauts, satellites, power grids, and ultimately also our internet, without which I wouldn't even be speaking to you. I thank you very much for your attention and for addressing this important subject. Thank you very much.
Okay, thank you very much. And it's a really interesting presentation, also because Mr. Dancing gave to us a clear vision of ESA and also described the steps for the next year, and also shared the ESOP experience, and that's explained the importance of this topic And what is important to underline that how we can make the difference through to save space and to establish a commercial leadership in orbit servicing. So thank you very much. Now I move to the next speaker is Ambassador Soni Ducaru. He's the director of European Union Satellite Center. He has bridged the technology policy gap and the impact of technology on the security. So I leave the floor to you.
Thank you. Thank you very much. Indeed, very honored and pleased to participate at this conference to bring you the perspective of a very operational European Union agency in the field of security and space, including space security, but also having a bit of a crossover relevance, because SATCEN provides security from space to Earth through geospatial intelligence analysis, but also security for space due to its role as the front desk of the Space Surveillance and Tracking Consortium of the European Union. Let me try to share my brief presentation, and I will do it in a minute. Okay. Is it shared? Because I thought the screen is shared.
Not yet. Maybe you start the presentation. Then
because my share button is not functioning. I don't know why. Let me try to do it again.
Did you open the presentation before?
Yes.
Okay.
Okay. I opened before, but my share button is not enabled. Sorry for that, because frankly, we are in a geospatial intelligence business, and a slide speaks more than 1,000 words. Let me try to upload, in this case, the file, because the screen is not allowed to be.
Okay. Our director is.
I did do it at a trial, but okay, and it says that it doesn't want to be shared because the file is too big. The size limit of the file is 50 megabytes. Sorry for, I don't know.
I don't know if we can help Mr. Ducaru. Federico, it is possible? Okay. Okay, we will come back to Mr. Ducaru when we resolve this technical problem. Now, I am pleased to introduce Mrs. Artiola. She's a Secretary General of ISOA, and she has led the expansion of ISOA that represented the interest of 22 global and regional satellite operators. And under her leadership, she showed the benefits of satellite communication for a more inclusive and safer society. So please, the floor is yours, Art.
Thank you so much, Christina. It's my pleasure to be here. I hope everybody can hear me. I'm just going to pull up my slides as well. If you give me a second. Share screen, share slides. No, indeed, it won't let me share my slides, but it will let me share my screen. So we'll do that. Could you just confirm that you can see my slides? Could you confirm you can see my screen?
No, we
No?
don't see. No, nothing on big.
Okay. Yes, just allow me one more time. Is it working now?
Yes, it's uploaded. Yes, okay.
Perfect. So thank you so much for inviting me to present to you today. I'm going to talk to you about the satellite operator perspective on space sustainability. For those of you who don't know ESOA, let me take a second to introduce. The association today represents 22 operators. Some of them are global companies, some of them are regional, but they operate satellites across all different orbits, GEO, MEO, and LEO. ESOA is a CEO-driven association, so led by the chief executive officers of each of its member companies. I actually want to start my presentation by sharing a short video with you from the World Economic Forum's Global Future Council on Space, which I have the privilege to be part of. It's a very short video. I'm just going to share that now, and I hope you can hear it. Forgive me. So that showed you that I think that video provided a stark example, good snapshot of how much we rely on space services here on Earth. But there's also an economic dimension to this. The space sector overall is generating billions of dollars in revenue across the manufacturing sector, the services sector, the launch industry, and the ground sector as well. And if we look to the future, I think the importance of satellite communications for tomorrow's data-driven economy is absolutely unquestionable. We do believe that the satellite systems that we see today across all of the different orbits are going to be enabling connectivity in a way that no other technology can do so for many different vertical sectors. But as we all know, the situation in space is not quite as rosy, and the outlook for the future is very uncertain compared with the outlook for connectivity on Earth. We could argue that the orbits are already unsustainable. Of the around 34,000 objects that are larger than 10 centimeters in space today, only 4,000 of them are active satellites. And millions of objects less than 10 centimeters are also orbiting the Earth. And we know that even small debris can destroy active satellites. As we've seen recently, collisions produce large quantities of debris, and those pieces of debris remain a threat for centuries. When it comes to the satellite operators, they are extremely committed to making a difference as best they can in this field. The ESOA members have decades of experience in operating satellites safely, especially in the GEO, HEO, and MEO orbits. They have an in-depth knowledge of regulations and guidelines because they have needed to comply with them at different levels for many, many years. Going forward, they're committed to sharing data, to supporting the development of new norms, regulations, and guidelines, and of course, committed to continuing the dialogue with the government bodies and stakeholders who are going to bring these norms, regulations, and guidelines eventually, we hope, into being. Based on our position, ESOA has made recommendations for action, and they concern 3 different areas. One is space debris mitigation, one is remediation and disposal, and another is space situational awareness. These are the 3 areas in which we are calling for a dialogue and action between industry and government to help protect the space environment. However, there are already actions being taken today. Data sharing is one of them, and I did want to spend a couple of minutes emphasizing this point. Because the operators take the risks in space very seriously, they have invested millions of dollars into satellites. They do ensure that they monitor very, very carefully the design, the quality, and the resilience of their satellites. They exchange between them a maximum of data on incidents and space and on the space environment, and many of them have sensors on board their satellites. One of the things that some of the ESOA members did many years ago was establish the Space Data Association, also known as the SDA. The SDA is an industry initiative through which public and private operators are voluntarily sharing data on a contractual basis into an automated system. It has 2 key advantages. One is it is providing conjunction assessments to avoid collisions. And secondly, it's providing clear points of contact within the different operators. As the operators are increasing the number of satellites that each one of them may be operating, it's really important to know who you should contact in each one. Today, the SDA members are sharing data, real-time data on maneuver and positioning to track 274 and 483 different satellites, GEO, LEO, and MEO. It is an important example of meaningful action that can be implemented quickly, simply, and cost-effectively using a mechanism that is already in place. And I do want to emphasize that because when it comes to space sustainability, very often we're talking about what needs to be done in the future. But we should not forget there are already things that are happening today and that we can build on. Today, the SDA members pay $10,000 per year for an operational service. If you compare that number with the value of their investment, it really is nominal. But we know that a lot more data needs to be shared from many more operators, both public and private. As it is today, the SDA cannot scale for mega constellations without public support. Scaling for constellations with thousands of spacecraft will require additional funding. I do want to make the point that the fact that the SDA has its heritage in industry, it is set up by a few satellite operators, should not prevent it from being scaled up, and that should not be a barrier to public support. At the end of the day, until there is a public system which can offer the same quality of service, it is only a stopgap for now. Another area where we see a lot of activity is active debris removal. Data sharing on its own is not enough. We know that objects also need to be removed from space. Some operators are taking actions to facilitate the active removal of spacecraft. One of our members, OneWeb, has ensured docking plates on its satellites to enable precisely this. And this is a good example of responsible behavior. At the same time, removal technology is also developing. We saw Astroscale's ELSA-D spacecraft perform its proof of concept earlier this year. And now we're looking forward to the ELSA-M spacecraft, which should hopefully demonstrate removal of multiple retired satellites in a single mission by 2024. Debris removal is important, but we have to remember, in view of the hundreds of satellites which are being launched right now, that debris removal is always likely to be years away from being done at scale. And in the meantime, the problem continues to grow. I want to suggest that we look at space sustainability in the context. in the context specifically of climate change, which provides a good comparison. On Earth, with climate change, many actors saw it coming. They predicted this crisis years ago, but the lack of swift and coordinated action led to what we are seeing today, the natural disasters and extreme weather events on all continents. In space, again, we can see it coming. The absence of a harmonized regime for space sustainability could, in the not so distant future, make space completely unusable for the services that we rely on and that we saw in the video from the World Economic Forum. In the case of climate change, it may already have gone too far. But in the case of space, we still have access to space. That means that we still have a chance. For now, it is still a case of if and not when. So ESOA members firmly believe that space can still be preserved, but they do believe that the time to act is now. So I want to close my presentation by inviting you to have a read of the space sustainability paper which ESOA has published in September, which you can find on our website, and I'm providing the link here below. Thank you for your attention. I hope this presentation was interesting for you. Thank you.
Thank you, Mrs. Holla. No, this is a really interesting presentation, and from your presentation, we understand the importance of the point of view of the satellite operators. That means, in your opinion, what is the role of satellite operator and how can they have a proactive role? In particular, ESOA, how can play a role in the speeding up the setting of the European regulatory framework aiming to protect the space assets for the debris?
I do believe that the satellite operators through ESOA also have a very important role to play. If we look at all of the satellite operators around the world, the private sector as a whole, and you consider the size of their aggregate investment, it is really, really fundamental. It is so important. And we have heard from the previous speakers also how, you know, in a day without satellites, there would be so many services that just cannot be provided. So I do believe that the satellite operators need to be instrumental in working with governments, regulators, and other policymakers to help craft the actions, the norms, the guidelines, and the regulations that we need to bring into play. However, as I highlighted, I think that the operators are already being very proactive themselves in sharing data. And while we see different regional initiatives coming into being, we could already encourage or incentivize or even oblige, I don't know, operators from all around the world to participate in the SDA. I mentioned that the investment is negligible compared with the investment in space, but also compared with the benefits that they receive from the conjunction analysis provided by the SDA. So I really think that we need to think, when it comes to space sustainability, we need to think pragmatically as to what can be done soon. Thank you.
Thank you to you, and I am really happy to you are being with us today. And now I am pleased to introduce Mr. Stefano. Sorry, because we come back to Ambassador Sorin Ducaru.
Thank you very much. And
okay, I think that
apologies for the
solve everything,
and also the lack of connectivity. Okay, I think you can see my slide, and I will move on in a fast pace. I was mentioning that SATSEN is indeed crossover operational agency that knows the value of using space assets for security and defense, because it provides geospatial intelligence analysis for EU member states, for the EU as an organization with all key bodies from Frontex, the European border management agency, maritime security agency, but also for decision making at the level of the council, of the external action service, and it also supports other partner organizations such as the OEC or United Nations or Organization for the Prohibition of Chemical Weapons for its activity. And it is key also in providing the kind of analysis needed for operations and missions, including civilian humanitarian missions of the EU or partner organizations. But SATCEN is also contributing for the security in space, the security of our space assets, because it offers the interface between the member states of the European Union Space Surveillance and Tracking Consortium with the users. It provides this front desk role, and therefore is supporting the security and safety of our space assets. In a nutshell, the core activities are also supported by the development of tailor-made capabilities, including IT, software and artificial intelligence, dedicated software in-house. It provides training for member states, for all the partners, and of course it's engaged in close cooperation with other EU bodies and partner organizations. It's based its activity on commercial satellites, on the Copernicus constellation of the European Union, but also benefits of some access from governmental satellites, and it is involved very, very significantly in crisis management, from support to humanitarian aid to other kinds of missions of the European Union and its partner organization. Here is an example of support for OEC, a battle damage assessment in eastern Ukraine. There can be other examples. The partnerships with the EU Space Surveillance and Tracking Consortium, with the European Defence Agency, Group of Earth Observation, European Space Agency, but also with the Commission through Copernicus, through EMSA, Frontex, and her participation in Horizon Europe program is very, very close. But let me now come to the aspect of SATCEN activity which is linked.
Mr. Ducaro, sorry for interruption. We are stuck on the first slide of your presentation. Try to close it again and make it run again.
Oh, sorry.
Okay. Yeah, don't worry. Just run the presentation before you can share on StreamYard, so you can select the screen, the specific window.
Yeah, I don't know why this happened. So let me start sharing again. Is it visible right now?
Right now we only have the slides. So
which
now it's number 10. So SATCEN role as ST front desk.
Okay, I'm not going to go through the other.
Okay, you keep going this way. Okay,
let me focus on this one, because otherwise, or I will just
Okay, yeah, we can see the slides now. Sorry for interruption.
No, can you see it on the whole screen? Yeah.
No, we are back on the PowerPoint only. It's not the presentation.
I don't know why this is happening.
If you go on share screen after you run the presentation from PowerPoint, you not just open the file, just open the whole presentation.
Can you see it right now?
No, not right now. Try it again.
Okay, let me do it this way, because I'm not going to. Can you see it right now?
Yeah, right now we are at slide number 9.
I will leave it like this and not put the full screen. It seems something happens when I share the whole screen. Yeah.
Okay.
So
sorry for interruption.
That's I don't know why. The role in the SST consortium is that of providing the services of collision avoidance, re-entry, and fragmentation analysis for and providing the front desk for about 130 organizations and more than 240 European registered European satellite operators. It's an expertise of over 10 years, and as one can see, the collision avoidance aspect is probably the service that requires most of the interaction with our users. But then every now and then, it was recently in this year, re-entry prediction, as well as fragmentation analysis. Let me move to the next slide. So the way it works, the sensors are belonging to the member states of the SST consortium. They're providing the data. And what the Frontex does, it has developed a platform, a portal, whereby this data is transmitted to users, including alerts whenever there are dangers of collisions or dangerous re-entries. There is also focus on developing key performance indicators, user coordination, and communication and activities of our task force whenever there is a specific danger of I would say potentially catastrophic event. And let me give some examples that have been quite, I would say, visible this year, namely the February collision avoidance maneuver for Galileo satellite, and there have been some sequencing here from 25th of February until mid-March, where the collision task force has been activated, and it has been in close contact with its users to provide the latest information and data coming from the relevant sensors of member states. In terms of re-entry, we had a famous case this year of the component of Chinese rocket that has re-entered atmosphere in an uncontrolled manner after the launch, and a number of sensors from member states, from radars to, for example, telescopes, have monitored this activity over quite a long time span. And because there was a probability of potentially re-entry over EU territory, and this is seen here on the map with red, the contact with the relevant emergency management agencies of member states that were in those areas of probability of re-entry and collision due to re-entry have been kept in close, closely informed, and there have been close contact by the task force with them. And last but not least, the most recent anti-satellite launch by Russia that made the news. Satsen has been following and also developing the models of fragmentation and debris creation, and has informed its users accordingly. So to trying to conclude, because I don't want to prolong this presentation, coming from a perspective of a very operational organization. The point that I wanted to make is that the aspect of space security has become, and it's a growing issue. I would like to quote a recent article, I think it was December 6th, by French Defense Minister Madame Florence Parly, who mentioned that if space was considered like the new frontier, a number of decades since the 1960s, there is no doubt that today it is also a new front on a new battlefield, space battlefield. And space is indeed today a keystone of our defense. And it's therefore important for the European Union to focus its political attention, but also the necessary capability development and resourcing priorities related to the security, not just safety and sustainability, but also the security and defense of space. And in this context, SATCEN is one example, along with the elements of the European Union space program, along with the Copernicus, Galileo. SATCEN would be another concrete operational assets that gives the European Union and its member states an autonomous capability, both for the use of space assets, space sensors, electro-optical or electromagnetical, to support security on the ground, on Earth, but also to support the security of space or in space. From this point of view, it was the High Representative Joseph Borrell who visited a year ago SATCEN and who mentioned that it is important to include SATCEN also on a political orbit to give an example of operational capability that could be a model for the development of other capabilities. Let me also mention that next year SATCEN will have its 30th anniversary since its activity started in 1992 as an agency of the Western European Union and became 10 years later an agency of the European Union. And at the ministerial level board that took place in May this year, the 27 member states expressed growing level of ambition for SATCEN in the upcoming years until 2027. We're therefore also expanding physically the capabilities or our facilities on the ground in Madrid, but even more so, we're investing in making the activity more efficient through introduction of artificial intelligence and modern tools to use the growing ocean of data related to space that we are obliged and challenged to manage. With this, let me mention that we're looking forward to play a growing role linked to the level of ambition of the European Union and member states in the fields of security, defense and space. Thank you very much.
Okay, thank you very much, Ambassador. This is a really interesting presentation, and we understand also the importance of SATCEN, and there is a clear message for us. Just a few words, if you want. What do you think about the new proposed services such as debris remediation and debris mitigation?
Well, I think that we have to have in mind all options in order that are possible and that are becoming feasible through technological development in order to clean up the debris in the different orbits. And I think it was mentioned in one of the previous presentations that we are far from keeping up with the growth with the exponential growth in space assets, in new launches of new satellites. And the point is to be able to invest in these technologies, use all tools that the EU has to support innovation. And I know that, for example, both the EU Commission through space program, through Horizon Europe, also ESA are prioritizing this aspect in order to be able to do something better than just collision avoidance by moving the valuable assets from their current orbits. On top of it, we should also consider the aspect of developing what should be called norms of responsible state behavior in space, in outer space. So there has to be a double approach, making sure that we are avoiding this proliferation of debris, and on the other hand, developing technologies to help clean the current mess which we are already facing on the different orbits.
Thank you very much. Thank you also to be with us today. Now I will move to the next speaker, Mr. Stefano Iannitti, Head of Security of European Union Space Program Agency. He is one of the most contributors to the development of security aspects of the EU space program, like GovSatcom. Mr. Iannitti, the floor is yours.
Good afternoon, everybody. It's a pleasure for me to be with you. Today, I'm going to give you a presentation about the experience of the EUSPA, our agency, for what concerns the protection of the EU space assets. First of all, let me give you an idea of what EUSPA is. EUSPA is the EU agency for the space program. It's an agency established with the new EU space program that is collecting all the previous space programs of the EU and adding new ones, in particular Copernicus for Earth observation, Galileo and EGNOS for navigation and positioning systems, and then adding new components, as they are called by the new regulation for the space program, like GovSatcom for satellite communication for governmental user, and others like SSA, SST, and other initiatives that are being coordinated by the European Commission. The regulation for the space program establishes, like I said, an agency, which is called European Union Agency for the Space Program, also the acronym EUSPA, It is established on the basis of the what was the European GNSS agency, the GSA, which was the agency in charge of the mainly of the Galileo and EGNOS programs. This new agency, the EUSPA, is a user-oriented operational agency, of course, contributing to the EU space program, but also to sustainable growth, security, and safety of the EU. In a nutshell, the agency is located with its headquarters in Prague, in Czech Republic, but it also manages other centers in Europe, in particular the Galileo Security Monitoring Centers, which are located in France and in Spain, the GNSS Service Center, which is again located in Spain, and the Galileo Reference Center, which is located in the Netherlands. There are also other centers and offices that that belong to the agency, and you see the agency growing now from what was the GSA to EUSPA, also in increasing the number of staff, for which there is quite an important growth expected until 2023. What does the agency do mainly? First of all, EUSPA is the manager of the exploitation of Galileo and EGNOS, and this is done in close partnership with the Commission, the ESA, and of course other public and private partners. We take care of the operations of these two systems, in particular for what concerns the maintenance and the improvements of the system in operation. We provide the services of the systems and the respective service facilities. Then we also take care of the preparation of the security accreditation requests that are made to the accreditation authority, and I will explain this a bit more later on. And as of launch 15 for Galileo, the agency will be directly responsible also for this activity. Last but not least, for what concerns the GNSS systems, the agency support the design and development and the specification of future systems for what concerns all the exploitation-related matters. I mentioned a bit about the preparation of the security accreditation requests, and this is because the systems and the components of the space program are subject to a security accreditation process. And this is an essential process which is part of our security framework that is implemented by the agency. And the agency clearly follows the full life cycle of security of the space components and overall of the space program. And this is done through three main layers. The first one is the one devoted to the security accreditation that I was mentioning before. The security accreditation is a sort of certification process for which an authority is established inside the agency. It's a body of the agency. It's the Security Accreditation Board. This board is composed of representatives of the member states and evaluates and assesses the security risks associated to the design, development, implementation, and operation of the systems that we operate. This is the first layer. One of the main layers is the second one, which we call security layer. It's the one that ensures the implementation of the security governance, of the security policies, the security requirements and the standards. It is the one that implements the cryptographic requirements. It introduces and follows up cybersecurity issues. This layer is also in charge of what is called operational security for Galileo and EGNOS. This is a new concept that has been introduced as such in the new space program regulation, and takes care in particular of the security risks and threat analysis for the systems. The third layer, last but not least, is an operational one. This layer is linked to our Galileo Security Monitoring Center. It is an integral part of the Galileo infrastructure and monitors 24/7 the security of the system. It's our security operation center, which also provides, from an operational point of view, access to the public regulated service, which is a governmental service provided by Galileo and accessed by governmentally authorized users. So lots of security. Security is in the DNA of the agency since the beginning of its establishment. Why all this security? The reality is that we use the space system for our daily life, and space systems, space assets, and the services provided by these systems are clearly fundamental for our lives. And they support applications and operations which are critical for security and safety on Earth. That's why the space assets have to be protected. But protected from what? Here we have to have a look at the threat landscape. And looking at the picture, clearly in any space system, we have a space segment, but also a ground segment, clearly. In our setup, we cannot neglect a third segment, which is the user segment. This is because our systems usually provide services to users. And this means that when we provide a service through space systems, through our space component, we have to consider the three segments. So from what are we protecting these segments? First of all, a typical threat is belonging to the kinetic physical category. You probably read in the news some weeks ago about the exercise done by the Russian with an anti-satellite missile, basically destroying one of their satellites. This clearly created other problems for what concerns space debris, which have been also introduced and presented by the director of SATSEN. And clearly this is a type of threat which is important also for our assets. Clearly this type of threat would represent, in case of happening, a sort of act of war, and this clearly represent also deterrent for any actor to perform this against like a foreigner system. Nevertheless, this is something that it's becoming visible in the news. There are space powers who are testing their capabilities for this type of attacks. We have to take them into account. There are other threats which are still physical, but not kinetic. Non-kinetic means that they aim at destroying and damaging the assets, but without a physical contact, for example, through high-powered lasers or powered microwave. These type of attacks are clearly quite sophisticated and can be performed, we believe at the moment, only by strategic threats. Nevertheless, this is something that we have to put in the picture as well. And then there are threats which belong to the electronic category. These type of threats are more affecting the link between the space segment and the ground segment, and why not between the space segment and the user segment, which has to be taken into account. These type of threats are mainly related to jamming of the radio frequency band in order to disrupt the communication between the segments. Or more sophisticated type of attacks like spoofing, which are more affecting the users, I would say, because with this type of attack, the users would receive a fake but still a recognizable message, which indeed is not the authentic message coming from the satellite. The last type of threat is the cyber threat. The cyber threat is clearly affecting the space system like any other IT systems. We know that a cyber attack aims at many objectives, which could be interception of data, monitoring of data, exfiltration of data, or on the other hand, data corruption, or aiming at taking control of the system and then of the satellite. Clearly, the cyber threat is very difficult to counter because it's very unbalanced. We know that the attackers always have an advantage with respect to the defenders, and it's very easy to start also because with the cyber attack you can also perform distributed types of attack, and it would be also difficult to understand exactly where the original source of the attack is. So in this framework, and focusing in particular on cybersecurity, of course we started to gather experience with our systems, in particular with Galileo, and we have identified 4 main security challenges in this respect. First of all, it's the security by design. This is because the original system concept for Galileo was focused on the mission performances, and we see it already today because Galileo represents a first-in-class system for what concerns accuracy in positioning and in navigation service provision. The security layer was added on top of this first mission layer, and clearly it is effective. But today the concept of security by design clearly pushes us towards design where security is accounted for from the beginning of the concept and on the design of the system. The second challenge that we have to face is obsolescence. This might sound trivial if you think about it, but then when you have to deal with it, it's not that trivial anymore. The fact is that it takes some time to design, develop, implement, deploy, operate a space system. And this means that the time between the initial concept and the actual operation of the system might be very long. And once you launch a satellite in space, you basically live with the technology that was defined some years before. And if you think about the life cycle, the lifetime of a satellite, that could be also 10 or 12 years, then at the end of life of the satellite, you have to deal with the technology which is already from 10 to 15 years old. This is clearly a challenge. You cannot change the technology on board. Clearly, you can patch the satellite, but nevertheless, apart from the software patches that you can perform, the technology is what it is. Another challenge is the worldwide distribution, in particular of the ground segment. If you look at the ground segment of Galileo, you see ground station located everywhere in the world, even in remote locations. this means that you have quite a big network which is geographically distributed worldwide that has to be protected. You have to protect these multiple sites globally, and clearly this is a challenge. Clearly you can monitor the site from the control centers. I have a central monitoring. You have the GSMC, the Security Monitoring Center, monitoring them, but nevertheless, if there is any maintenance activity, for example, that has to be done on one of the sites in remote location, making it happen in real time, clearly this is a challenge. The fourth, but not less relevant challenge is related to the supply chain. The space systems are very complex. We've seen we have a space segment, we have ground segment, we have user segment. Each of the segment is composed of different elements, components, and suppliers, which basically provide different technologies. This means that when it comes to find a way to implement and ensure compliance to the cybersecurity requirements, this can be very challenging because the supply chain is very long. Making sure that all the components that are used in the chain fulfill the security requirements, it's really very difficult and clearly complicates the picture. This is for what concerns the cybersecurity challenges. But I also want to tell you a story. This is fortunately a story of success, which is related to a potential collision that we might have had at the beginning of this year. It was at the end of February when our colleagues from the USST warned us that there was a risk of a collision between one of our Galileo satellites and an Ariane 4 inert upper stage. You can imagine, launched in 1989 in geotransfer orbit, and it's still there orbiting around our heads. This was quite scary. It is still scary because the upper stage is still there, threatening also other space objects. And our colleagues of the USST told us, look, there is our prediction model says that there might be a collision on the 7th of March. Our flight dynamics engineers, of course, started to work on this. And day by day, clearly the calculation showed that the probability, the likelihood of collision was increasing every day, and the risk and the probability of collision clearly was becoming worrying. That's for on the 5th of March, there was a decision to activate the collision avoidance maneuver. The satellite services were switched off. The satellite was commanded to go out of its orbit. We waited for the inert upper stage to pass by. We say goodbye, and then we waited the right time to put back the satellite into the right orbit, and then turn on the services for that satellite again. So this is clearly an event which is not an intentional attack, as we can imagine, because clearly this is very accidental, and it's due to the fact that the space debris is becoming a serious problem, and the director of SATSEN clearly mentioned this in his presentation. Here, what I wanted to show was an example of this problem becoming a reality, and the need of protecting the EU space assets, which are so strategic, also from this type of threats. How can we protect then the EU space component? Out of our experience, we have identified a strategy that we would like to pursue in order to protect better our space component. First of all, I think that now that we have an EU space program, I think we have to take advantage of this, and we should find a way to integrate all the space components in order to support each other. We've seen that the contribution of our colleagues of the USST was fundamental for the collision avoidance happened at the beginning of this year. I think that USST is a fundamental component of the space program for the monitoring of the space assets and for the protection of the space assets. And for this, there are elements that have to be enhanced, improved, and developed. In particular, we should focus on the on sensors, because the more the sensors, the more we can monitor and track. But also, when we have to deal with all these data coming from the sensors, I think that we have to work a lot on big data analysis and artificial intelligence for automation of analysis of these data coming from the sensors. Another element that is important for the improving resilience of our space component is the contribution that GovSatcom could give. Indeed, in particular against cyber attacks affecting the links of the ground segments of our space system, GovSatcom could provide an alternative communication link, could provide a redundant communication link that could be used in case the normal and nominal links are down for whatever reasons. Also, it's important to focus on the critical technologies and the emerging technologies like the quantum technology. There are initiatives that at the moment are been started by the European Commission, like the Euro QCI. These technologies have to be clearly supported, but also we have to make sure that we have a long-term vision for the exploitation of these technologies and to understand how these technologies are useful for all components. And then there are synergies to be developed, in particular for what concerns the applications. Some of the applications and the services that are provided by the EU space assets are dual by definition, and this means that synergies can be exploited for both the civilian and defense users. Then I mentioned it as one of the challenges for the new generation of the systems, or for the new components that we are developing. We have started to apply the security by design concept, which is very important. So security is integrated from the beginning, from the concept of the system. For what concerns the monitoring on the threats and the real-time monitoring of the threats, we leverage on the cyber threat intelligence, mostly provided by the member states and the entity of the member states, as well by the EU CERT, with which we have a great collaboration and which provides us with daily threats, alerts and monitoring.
Stefano, sorry if I interrupt you, but the time is running. Please, if you can go to finalization of the presentation.
Yes,
sorry.
of course.
Thank you.
No, it's okay. We focus on this, and in particular then on the security governance. The role of all actors is important, and the operations at the core of security. The entity which is in charge of the operation is the one that is in charge of the overall security of and the protection of the assets. So just to conclude, the assets, space assets, are important for us. The space program at European level is an opportunity, and we can leverage on all the space components which complement each other and can support each other for their protection. Our agency is in charge of the definition of new application and the provision of services for secure and safe life. And the entity which is at the center of the operation is the core of the protection of the space assets. Thank you very much.
Stefano, thank you very much for this interesting presentation. I have a question for you. Nowadays, space providers develop services in telecommunication, geoinformation, and navigation, supported at the transversal level by artificial intelligence and cybersecurity. Have you any recommendation in such respect on security point of view?
This is a very complex question now, Christina. What can I say? Yes, I mentioned, I touched a bit the two aspects related to the artificial intelligence, which is essential for the processing of the data. This is fundamental because the amount of data that is coming from the space assets is as such that it's humanly impossible to analyze all the data one by one. So for this, I think that it's important to invest also in these technologies from an application point of view for the use of the space assets. And for what concerns the security aspects, clearly it is very relevant to invest in new technologies for not only for the protection of the space assets, but also for the protection of the services that are provided to the users. And I'm referring to communication services, navigation services, and also Earth observation services. Whenever data has to be delivered to the user, we have to make sure that the data is authentic, which is integer, and it's not counterfeit.
Okay, thank you very much, Stefano. Thank you, because your opinion is really important for us. Okay, thank you. And now I am pleased to introduce Mr. Jacob Geer. He is head of space surveillance and tracking for a UK space agency. He leads a mixed team of technical and policy staff responsible for tracking satellite and space debris. The floor is yours.
Thank you very much, and good afternoon, everyone from London. I'm here today and very pleased to be speaking with you again, my European colleagues. Since the last year and Brexit, perhaps maybe the UK has not been able to speak as much with you in forums like this as we would like. But today is a chance for me to talk to you about our plans, our intentions around space surveillance and tracking. So why we do this and what it is we do and why we think it is important to work together. I have some slides to share with you. So firstly, let me start with why it is we think this is so important. And I know that many of you in the audience will understand this already, but it is always good with these presentations to talk through why it is exactly space debris and the space environment is important to the public. So we have here a number of different examples that we typically share with members of the public when they ask us, why should I care about space? Why is protecting satellites important to me? And we remind them of how much they rely upon space in their everyday life. So from the weather forecasting to the navigation on their phone or their communications they might use out when they're outside of the cities, or even the financial sector, so cash points, ATMs, and internet banking. All of these can rely in part or entirely upon satellite data and satellite services. And therefore protecting satellites is important to them, because if you have a day without satellites in your life, it will be expensive, it will be time consuming, and all of a sudden the things that you rely upon to get around or to live your life will not be there. But also, as well as the public, the satellite services which we depend on are important to the government, to our economy. In the UK, and I'm showing you now a more complicated diagram, we have our sectors, our critical national infrastructure sectors. And you can see here along the bottom in a semicircle what those sectors are, from governments and finance and chemical on the left, all the way through the energy, transportation sectors to health, food and water on the right-hand side. And to some degree, the satellite services you see on the top, from situation awareness, so SATCOMs, global navigation systems or PNT, and Earth observation, every single one of those sectors needs satellites to keep functioning. So our economy, our security, and our prosperity here in the UK and in other developed nations, including across Europe, all depend in part on satellites. So there is a government, a public rationale to protect those satellites as well. But of course, protecting those satellites is becoming harder. So we have a standard image. There are now lots of pictures, I think, of what debris in space could look like. Since the Russian ASAT test a couple of weeks ago, I think there are lots more pictures from telescopes and radars showing what debris actually looks like from the ground. But this impression is useful for communicating to people. Space is not clear. It is not a pollution-free environment. There are lots of pieces of debris up there that make it harder to navigate and operate in space, that present risk to satellites. The previous speaker talked about one collision. We monitor many more as well. That means actually satellites are facing more and more risk. And as more satellites are due to enter orbit, think of SpaceX, Starlink, think of OneWeb, think of Amazon with Kuiper, tens of thousands of satellites due to enter low Earth orbit in particular. This congestion and this risk will carry on rising. And that's why we think there's a need to do something about it. The numbers, and this is from the European Space Agency and United Nations Office for Outer Space Affairs, both of which we are very proud to be supporting in the UK, are generally quite staggering. If we think of maybe 3,000, 3,500 working satellites in orbit right now, compared to around about 34,000 fragments larger than 10 centimeters, so bigger than a can of Coca-Cola, or 128 million pieces of debris larger than a millimeter. The amount of debris compared to the amount of working satellites is staggeringly different. And it's quite often the scale of the problem, the scale of the amount of debris in orbit, which I think surprises people. But then people understand this is why we need to act. Why the UK, why the EU, why the US are all making efforts to protect their satellites with space surveillance and tracking. And here in the UK, we have a number of different solutions to debris, as well as space surveillance and tracking I will talk about. This is a diagram that we use internally that I share with you now. We have our pre-launch assessment where our licensing or regulation team will make sure that there is no new debris created or risks are minimized. We work with international groups, so the UN or the Interagency Debris Committee, to agree the long-term sustainability guidelines. From launch into operation, we then utilize alerts about collisions or other risks in order for satellites to avoid being hit, to avoid creating new debris. And at the end of life, we ensure that there is passivation, so maybe batteries or fuel is made safe, and that satellites re-enter safely within the 25-year rule or whatever it may be for their orbit, in order to ensure that no new debris is created. And this is important for the UK and our Space Industry Act, which came into being in 2018, has now been signed into law, gives a very modern licensing framework to enable these risks to be mitigated while still enabling businesses to come to the UK. We're very proud of that legislation. It really gives us a chance to both support business, but also make sure we are safe and sustainable with all of our space operations. Let me talk now a bit more about space surveillance and tracking. So that middle section, if we look at what we do in orbit. The challenge there, speaking again about debris, is large. If I look at now a diagram which shows the various different planned constellations, You may have your own opinion about how many constellations will reach orbit. This shows an example of some of them. And the different bands or orbits, as well as the different debris clouds or debris fields that we see. There are some very busy parts of space. So particularly between 500 and 600 kilometers, maybe up to 700, is quite busy. We see lots of Earth observation, as well as now increasingly satellite broadband constellations going here. Up to 1200 and 1100, pardon me. OneWeb in particular, the UK operates there, but there are others out there too. And this is now a year old. If I added some more constellations to this, you would see a lot more numbers, a lot more satellites planned, showing just how busy low Earth orbit is. So this challenge is what we're trying to meet. And in the UK, we've been working with the RAF, so our Royal Air Force, who have their own military capability. They've been doing it since 2008. We've been doing it since 2016 to try and monitor space, to reduce risks to industry, to our government and our military satellites too. We've been very pleased to work with others. So the UK was a co-founder of the European Union SST Consortium back in 2015, and we enjoyed working as part of that team, and I can tell you we miss working as part of that team as well. But we also work with others too. So the Combined Space Operations Center, or CSPO, and the Space Operations Center in the US. We have staff over there, military staff, as well as working between different nations. We work at the G7 group of nations politically, the Committee on the Peaceful Uses of Outer Space, the UN Committee, the Interagency Debris Committee, to try and realise international action, so changing the rules, the norms, the guidelines around space as well. And finally, we're now working on a further concept in the UK called the National Space Operations Centre, which started in 2018 and continues now, to really bring together the the military and the civil aspects of tracking space objects. So what the military called space domain awareness, and what we in the UK Space Agency called space surveillance and tracking. And that is continuing now, and we're trying to increase our capability in several ways. We typically split SST into sensors, software, and analysis. In the UK, all of this is underpinned by our investment in the ESA Space Safety Programme on the right-hand side there. We're the largest contributor to that programme, and we use that to really drive in our future research and development to make sure that we can continue to leverage the best in sensors, software, and analysis. Within each of these fields, we have a number of activities I would highlight to you. For sensors, we are awarding grant funding, so R&D funding, to our own industry to develop new types of sensors, so low-cost sensors, looking at LEO in particular. We maintain and use current UK sensors, so historical sensors, academic sensors. We pay them for their supply of data, either radar, telescope, or laser, to help us understand the space environment. And we're now recently procuring commercial sensor data from the open market, particularly for radars in low Earth orbit and telescopes for geostationary orbit, to give us even better data fidelity, accuracy, and timeliness to feed our SST services. We're looking at software and data processing. So the UK is a key developer of the ESA core software for SST. We also develop our own in-house software with the Ministry of Defence, which helps us to realise some strong UK benefits. And we've recently started exploring with grants artificial intelligence, machine learning, applying some of our wider expertise in these areas in the UK to the problem of space debris. And finally, on our analysis side, we've been trying to build the skills, the expertise, the capacity of both our civilian and our military analysts. This is not perhaps an easy group of people to try and increase. There are specific jobs, there are scarce skills to be trained here. So we're trying to really bring on that skill set in our workforce, our graduates, our PhDs, as well as in industry. And we've recently been starting to share our collision avoidance industries, our collision avoidance warnings, firstly within government, and from next year with industry as well. So with UK satellite operators, to enable them to benefit from all these things that we see within government, to avoid collisions and to better understand the orbital environment. This slide, which is quite busy, there are lots of different names or logos or people in here, shows some of the people that we work with day to day and more foundationally too. From the top, you can see some of those people that might use our service, both inside government and outside government, to understand collisions, but also some other aspects of the space domain. On the right-hand side, you can see some of our industrial and academic providers. So these are small companies, medium-sized and some very large companies that we work with that supply to us as an SST service operator. And to this, I could add companies like Numerica, who are now providing us with geodata. At the bottom, pardon me, we work across government to make sure that we have the best skills from across the public estate coming into us. On the left-hand side, you see our international collaboration. So the US, the EU, ESA, and the G7 are just some of those people we work with typically. It is a busy space. This is just the UK element on the top and the right-hand side. If we go European or international, it gets even busier. But you can see how interconnected all of the things that we do really are. Finally, it's not just about tracking debris. The UK has recently been very proud to announce some new studies. So to look at the initial phase 0 or phase A studies of going into space and removing at least 2 old UK spacecraft from orbit. We think this is important because it's there to demonstrate the case for active debris removal, to send 1 satellite up to remove 2 or more. That means that we are not creating the same problem, we're reducing it, but also as a step towards in-orbit servicing. So our intention is to allow the spacecraft, which goes up to deorbit these old defunct satellites, to be refurbished or reused for future. And that is, I think, a key market for the UK to look at, the in-orbit servicing market. We're already very proud to support the ADVIOS mission, so the Clear Space mission, which is Swiss-led as part of ESA. We are really keen to see how that develops and are supporting that heavily. But as well as that, we do these national missions because we see the need to act now to do something about space debris. And so that's why with ESA nationally and with other international partners, we're trying to do our bit as the UK. That was the end of my presentation. I wanted to say thank you very much for your time and happy to take any questions. Thank you.
Thank you very much. Very interesting presentation. And I have one question for you. Is how do you see the integration between space surveillance tracking and more operative services such as debris removal?
We see space surveillance and tracking as a key enabler for debris removal. So at the moment, maybe space surveillance and tracking focuses on collision avoidance and on re-entry and fragmentation. But there are more services for high precision space surveillance and tracking to enable rendezvous operations, proximity operations, which a debris removal mission will need to have. So we think there is a new market or a new service to be opened up there. And then, of course, SST is crucial to reducing the creation of new debris. So that is the most fundamental thing we can do, and we must keep doing no matter what. Thank you.
Okay, thank you very much. Now I am pleased to introduce Mr. Ignazio Dogliani. He is an expert of information management and corporate communication, and he is the CEO of CIPAL. Please, we can start with the video.
Welcome, everyone. SIPL was born in 1978 from the idea of a small group of electronic engineers. The founder members committed all their energies to create a veritable pool of aeronautical engineering with the aim of offering the leading players in aerospace and defense sectors a complete range of integrated logistics support services, including all the security authorization necessary for operating at the highest level of secrecy. The end of the 80s marked a turning point in the company history. SIPL chose to join the grand Italian group, Finning, managing to transform the difficult moment into an opportunity for growth and expanding its activities into automotive sector as well, to become a major provider of services to the leading companies in that sector. In those same years, to meet the need for security and safeguards for the technical and industrial information handled by Italian companies in the defense sectors, SIPL designed and patented cutting-edge products to protect confidential information, which led to the birth of the SIPL security sector. The latter half of the 90s marked another development. SIPL decided not only to provide system support services to its customers, but system design services as well. This led to the birth of the design sector, and by the start of the new millennium, SIPL was already a strategic player in the development and realization of aeronautical and automotive plant, structure, and field equipment. Today, SIPL is a dynamic company with over 400 highly skilled resources, capable of providing global engineering services. In the last years, SIPL has identified a solution for the digitalization and the integration of all the processes that contribute to the management of a road infrastructure, thus creating an asset management application for field inspection and maintenance. Our mission is oriented towards the creation of a platform able to supporting and managing all the process involved in the major works during the construction and management phases. We create digital twins of assets using technologies and devices that enable the sharing of knowledge to overcome the traditional limits of the vertical systems. As part of structural monitoring, SIPL, together with an ecosystem of partners, is implementing a monitor system that use integrated satellite and terrestrial data to provide infrastructure managers with very accurate information on the state of health of their infrastructures. The system is an integrated solution of dynamic and static monitor techniques supported by Earth observation data, rather to evaluate any instability of the surrounding environments. Optical data will provide information on awareness of the background situation of the bridge territory and to monitor changes in the surrounding environment. A wireless GNSS sensor network is able to detect small displacement of the surrounding environment and of the structural element of the bridge, like pylons, deck, etc. All these data are able to measure very small horizontal and vertical displacements of the critical infrastructure. Our goal is to provide a set of tools to check the physical and functional integrity of the bridge by monitoring the geophysical stability and environmental condition of the surroundings. In fact, satellite data integrated with ground sensor networks allow the development of predictive models of behavior for landslides and model for the prediction of hazard rates. Our solution represents an innovative operational tool designed for early warning and detection of possible structural failures, capable of integrating heterogeneous data from space with terrestrial sensors. An innovative element in our system is the use of blockchain technology for prevention of data tampering. The validation and signature services of data acquisition will ensure the validity and immutability of the acquired data. The blockchain services can be extended to any other type of data. The improvement of safety, quality, infrastructure implementation, in fact, is an important driver, especially in Europe and USA, where there are many problems related to the obsolescence of building materials and design techniques, load variation, and weather conditions. More generally, a reduction in the cost of monitor sensors and stricter regulation, in addition to the aging of the infrastructure, are driving strong growth, so much so the various market research are estimating an average compound growth rate in the period that goes from 2021 to 2027 between the 16 and 18%. Since 1988, SIPL has been part of the Finning Group, a privately owned Italian holding company operating mainly in the field of large public works. The group also includes companies operating in the fields of civil engineering, wine growing, and tourism hospitality. With turnover in continual growth and the support of a group that manages an overall business volume of 300 million euro per year, SIPL is a solid, reliable partner. SIPL mission is simple: to be an all-around, irreplaceable partner for the world of engineering. To us, safety and quality are the key, while pioneering through innovation. Thanks all for your time and attention.
Okay, this is very interesting to see the use of space data and terrestrial sensor for monitoring critical infrastructure. So this is a good example. Okay, now I am pleased to introduce Mr. Mirko Ermini. He works at a research and development facility, and he is head of innovative research of Italian railway network. Thank you for you be here, and the floor is yours now.
Thank you. Good afternoon. So I'm going to share my presentation. Okay, you should be able to see my slide now. So good morning, good afternoon. My name is Mirko Ermini. I'm an electronic engineer. I'm responsible for the innovative research area within the Research and Development Department of RFI, which is Rete Ferroviaria Italiana, part of Ferrovie dello Stato Italiane Group. In my intervention here, I will go briefly through the ongoing initiatives about satellite monitoring of the railway infrastructure within RFI. Just a brief introduction of RFI. Rete Ferroviaria Italiana is the national railway infrastructure manager in Italy, responsible for the maintenance operations and also the development of the infrastructure. Quite a complex infrastructure indeed, composed by nearly 17,000 kilometers of track, 2,200 of stations, almost 200 goods plants. About 3/4 of the network is electrified, and the entire network is covered by safety systems like automatic protection systems. In terms of medium long-term goals that are common with the whole Ferrovie dello Stato Italiane Group, and well inserted in the 2030 agenda, RFI is aiming to reduce its environmental impact, in particular to reach carbon neutrality by 2050, develop sustainable mobility in terms of increasing the percentage of passengers and goods that are moved across Italy by trains instead of through the road, and keep the effort to increase safety and reduce fatal events. In terms of stakeholders, RFI has a quite a number of stakeholders, in particular institutional stakeholders like Ministry of Infrastructure and Sustainable Mobility, Ministry of Economic and Finance, the Transport Regulation Authority, and the National Agency for Railway Safety. In terms of customers or applicants, we have mainly the railway operators like, for example, Trenitalia, NTV, and others that require access to our network and requires services and capacity on our infrastructure, but also regions which inside their territory establish, for example, minimum standard level for quality of services. And then other stakeholders like all the travelers, people with reduced mobility with a set of services dedicated to them, association and representative organizations, community and territorial institutions, and also the European Commission for what regards the international traffic. So what are the challenges that RFI faces for the future? First of all, the development of the rail infrastructure in terms of reducing the imbalance between public and private transport, increasing reachability and accessibility of stations, in particular for travelers with disabilities or reduced mobility, and generally speaking, reducing the gap in railway connectivity from north to south across Italy. But also all the challenges coming from the sustainability team and the sustainable mobility. So increasing the modal shift, reducing CO2 emissions, but in particular incorporating the impacts of climate change and facing the fragility of the territory as the railway infrastructure is actually part of the territory itself. In order to tackle with those challenges, innovation, technological innovation is a key factor. Here, just to say that we are aware of the fact that innovation is a changing paradigm, and now is more a matter of time available for the development and adaptation to new technologies. And here in the picture, you can see some of the relevant sectors that are basically showing a radical phenomenon of change that can affect actually the railway sector as well. So in particular, robotics and automation, autonomous driving, Internet of Things, and other systems of transport and etc. So coming to the specific topic of my presentation, I would talk about a project that we have defined basically in RFI, that is the infrastructure monitoring from satellite. Basically, we are looking for satellite technologies already available on the market that are suitable to improve our capacity in monitoring in a continuous and extensive way the territory where the railway is present, considering the specific requirements and needs for the railway context. Basically, the idea is to acquire satellite images, integrate them with the techniques based on artificial intelligence that can elaborate and extract data from images in order to enable a predictive approach and to anticipate potential risks or potentially dangerous situations. I'm not an expert of satellite missions, but I have reported here some examples of satellite missions that can generate those satellite images, in particular with high resolution, down to 10 meters or even less in some cases, and with a refresh rate that is less than 1 week. Looking to technology to elaborate those images, here I've reported some of them, in particular persistent scattering interferometry, that is basically meaning to measure and monitor the movements of the terrain, the Earth's surface, by analyzing two
images acquired at different times from satellite in order to see how the ground is moving, is it changing over the time. Change detection, that is, it means observing an area and generate attributes that can be observed over the time by periodical acquisition on the same area. And spectral mixing, that means basically extract and identify some specific components within a complex satellite image. In terms of our needs, we have identified 4 macro areas of needs. The first one is hydrogeological risk. As I said before, our network is covering the entire national territory, crossing also areas where the hydrogeological risks is higher. That means it's higher the risk of having phenomena like, for example, landslides that can impair the circulation of trains. So it's very important to monitor that area. Second, vegetation monitoring and control. That means vegetation that is growing up near the tracks. And here the potential risks are basically 2. One is reducing visibility. That means that train drivers might not be able to see signs and signals, and so to drive the train, but also obstacles falling on inside the infrastructure and on the tracks, so constituting also obstacles and potential damages for trains, like, for example, big branches falling from trees. Buildings monitoring mean that railway infrastructure is also present in urban context, where you can have new buildings or big working area where the ground is changing, and so it's very important to monitor what is happening around our context, I would say. And last one, control of difficult to access places. Here, the picture is very significant. You can see this train running on a rocky ridge along the sea, which is quite a difficult to access place for example, for maintainers. On those 4 areas, we have identified 2 main categories of what we would like to observe in terms of periodic observation and on-condition or on-event observation. So superficial movements for the identification of new instability never observed before, or to monitor the evolution of known instability where instability has occurred in the past. Observe the vegetation state along the line and distance between the vegetation and the rail. Observe the presence of new buildings constructed within a neighboring area of the railway, which is 30 meters on both sides, and track control in difficult to access areas, as I mentioned before. In terms of on condition, it's very interesting to generate flood maps or flood risk scenarios, identify the type of vegetation, and to classify the vegetation in terms of height and overall dimensions, or in terms of potential risk of obstacles that are falling on the rail. Control of buildings already identified, and checks in critical conditions. I would mention special events like, for example, earthquake. And consider that this observation shall be deployed on the national territory, so covering all the national territory. So basically, this is the concept. So we are defining a satellite application platforms with a highly automation level, able to process and send information to a user, so to our personnel, basically, based on long time series of satellite images, in order, and that's the goal, to support the decision-making chain regarding the monitoring and management of the infrastructure. So with the possibility of visualize raw data, have analysis services with a user-friendly interface, Also, combining data is very important, and if possible, also to the possibility to access and display high-resolution images in order to observe a particular portion of the territory where the railway is present. This is basically how the platform architecture looks like, where we have these satellite data, so the images coming from the satellite missions, through a data acquisition module that is responsible basically to manage the periodic acquisition and the on-demand acquisition. We filter and store the time series of images. Then we have a control manager that activates one of the 4 areas that I have mentioned before. And through the algorithms that are able to elaborate the images, it is possible to prepare reports that are visualized through a user interface, and it's also possible to run on-demand analysis based on specific needs. These are some use cases. For the visitation, it's important to realize to generate coverage maps updated on for example, on a weekly basis, but also to evaluate possible different aggregation levels monthly, seasonally, or yearly basis. Classification of soils, for example, in terms of presence of forest or urban context, also potential risk of floods or deforestation also, and the evolution of the classification itself over the time. Monitoring the deformation and subsidence of the soil in selected areas of interest, obviously, and generally speaking, functions of data aggregation and statistical extraction like temporal averages or counting of particular events. So this is basically where we are. So we have completed the definition inside RFI of this technical document that actually is a requirement specification that describes the platform with all the interfaces, functionality, and performance expected. And the next step, which is also where we are actually, is to start involving the experts in the satellite field, but also in the software field, in order to realize a first technological demonstrator of the platform and start understanding the real performance in a simulated environment. I think I have concluded. So thanks for your attention.
Okay, thank you very much, Mr. Mi. It is really interesting to see the vision of those who use a space system to protect and monitoring their infrastructure. So this is another point of view. I have just a question for you. Will PNRR be an important opportunity for RFI to improve its own infrastructure in relationship to space system?
So PNRR is a relevant investment plan in Italy. For railway environment is much focused on development of new capacity and actually increase the railway infrastructure itself. So it will be deployed on several geographical area, and so covering basically one of the most important investment in the future for the development of the infrastructure. So specifically in that field.
Thank you very much. Okay, now I am pleased to introduce Mr. Juan Tomás Hernani. He is the CEO of Satlantis and he is also a co-founder. The company is the leader producer of a specific technology, but now I leave the floor to Mr. Hernani. Thank you.
Thank you very much, Cristina, and thanks for inviting me to this fantastic conference, and thanks for the audience to be here with us.
Yes, I think I'm very honored to talk about the topic of infrastructure protection. I think satellites can do so much to really provide this function in a number of areas like railways that we listened in the previous presentation on electrical lines, frontiers, nuclear power stations, and such a big list of numbers. Let me share with you my presentation. No, let me see. How should I do it?
Just do the same thing as before. Just don't push the blue button. Okay.
Yes. Can you see
Excellent.
now?
Yeah. We do. Go on.
Okay. Thanks very much. Excuse me for the lack of expertise with the application. Okay. So the first reflection is related to the assets that we have in space running through the planet in GEO and LEO. Roughly, I think there are inventoried in 5,000 different operating satellites that are capturing and transmitting data. And basically, this is an engineering effort that is managed and dealt with engineers that talk about rockets, talk about methodology, about the preliminary design requirements to the flight model, which represents a business of 17 billion, so not that big, but in the end, has an impact in the economy of over 400 billion. But we have to be, I think, aware that more and more these assets are producing data, and that this data is more or less paying the activity of the satellites in the end. And this data is subject to the digital revolution. So there is more and more investments and more clients that are influencing the way that those satellites are being operated. And my message is that new space, which is a high part of these 5,000 satellites flying, is the enabler of new ways to produce this protection of assets. No, let's have a small reflection on how different space systems are behaving. And if we could refer it in terms of what is the challenge of infrastructure, what is the customer complexity demanding from the satellite mission, and what is required in terms of investments, we will position the traditional business of bigger satellites in a high end where there is a long lead time to develop those satellites, more than 5 years, and tens and hundreds of millions of euros that need to be deployed before the first services are even thought of. So the customer is very far from the idea of the mission that those satellites are being placed. So it's not easy to think that you can have a mission where you can look at your pipelines or your electrical lines based on standard approaches. I think new space is failing many times in trying to reflect the same behavior as the traditional space systems, but of course with less money and less time, but still far away from the customer issue. So I think the challenge today is to understand that an electrical company will have, for example, 15,000 kilometers of electrical line, mid-power, high power in the world, and they will have a requirement to revisit to protect against vegetation growth, for example, or train lines, as in the previous example, that have a certain geographical deployment and require a revisit of once per week or whatever, so that they have to accomplish a certain goal, and therefore you have to develop the mission for that. In the end, the technology challenge is that there is a satellite flying that needs to understand the language of light. So through the light, we can have a number of physical phenomena that we can focus upon and we can provide a number of solutions. So if we were able to tune the camera, the sensors that are embarked, to understand where the light is reflecting, the issue of, for example, methane emissions in a pipeline, or is detecting some SO2 emissions in a refinery, or a fire with the corresponding potassium emissions, then we will have a number of focus in different points of the spectrum, and we will know what to do, so that still we can have space in the detector, or some room in the detector to have a standard approach. But on top of the standard approach, we will provide an effort to look at methane emissions or to look at fires. So along the trajectory of the spectrum, we should focus in a number of sometimes very narrow band points that are revealing what is happening. This is today possible. So we can select the camera that is devoted to the mission. So the camera is not a payload that disembarked in a satellite to do a mission. The camera is the heart of the solution for the customer problem, and it's at the very center. So the camera is, in fact, conditioning the performance and the cost of the full mission. So better if you choose the appropriate sensors on board, rather than thinking that this is a commodity that you could select from the market and just embark. So the camera is going to fix the satellite size. Normally, the camera is half the size. So if the camera weighs 100 kilos, the satellite will weigh 200 kilos, roughly. So you will have to launch in space 300 kilos. So that you are fixing the mission cost at the time that you fix the camera choice. So today, there is no longer, this model of upstream and downstream. You have upstream companies and activities in the economy that simply fill in servers for the service of other companies in the downstream. The only connection between downstream and upstream is servers of data. This is a traditional model. Today, upstream and downstream are a single set of delivery where you can provide solutions for customers that are focused in the challenge that will provide hardware, software, and services. So the sensors are evolving from just resolution and weight into a multiple requirement for a certain infrared capacity, a certain listening to sensors, the concept of visual IoT in the infrastructures, of course, the concept of multispectrality, the revisit, and the agility. So this is the pentagon that defines what a sensor should do. And of course, the implication in terms of cost is that instead of looking at a square kilometer in terms of tens of euros, you will realize that it's cents of euros, but of course devoted every week to the same problem. So you need extreme miniaturization, you need a lot of onboard computing and light computers that provide these quadratic transfer functions. You need agility to follow on structures in frontiers or pipelines or electrical lines. And you need a science case that understands very well how to detect the cases that the customer is concerned about. We in Satlantis have structured these challenges through a number of technologies, from the very small CubeSats to the medium-sized microsats in the range of 50 kilos, to the higher size of minisats in the range of 100 kilos, that will give you resolutions from 2 meters to 50 centimeters in the total. No? There you have some examples of what you can do. So we can have a look at some there's an infrastructure like an airfield, and we can have a zoom, and we can see the blades in the helicopters, saying that with a small camera, we are looking at 70 centimeter resolution. We are looking at the lines of the takeoff road, and they are separated. Again, we are arriving at these 70 centimeters, or even in the aeroplanes, we can look at the motors over there. You can go into urban infrastructures, and you can see the harbor activity that is so many times needed for activity monitoring and protection. You also have cars in the city, in the roads, where you can perfectly look at what is happening over in that type of infrastructures. And this is the example that I wanted to make in terms of agility, so that you know that when the satellite moves, you rarely can leave the orbit, and you can only look at what is the blue line in the picture. But in our case, you can see how we can depict the frontier, which imagine it could be an electrical line as the satellite is progressing, which means basically that we can provide 100 times the impact if we can select what the customer wants to look at, compared to non-capable technologies where you can go in one pass and then another pass, and in the end have your electrical line photographed. So in asset protection, agility is the first quality that you should ask for. Our company is now involved in 5 flight missions. We are about to contract a 6th flight mission before the end of the year, which will be a super microsat that includes SWIR and submetric resolution. So it's something that is really a new feature in the market that is providing customers with the capacity to protect. The first mission was made with Japan in JAXA last year. Second mission is, by the way, next year. Next week, we will launch 21st of December from Kennedy for a DoD mission in the US. Third mission is the Urdaneta mission that we will launch in June. The fourth mission is a UK mission for dual monitoring activity in the oil and gas sector. And the fifth mission is detecting methane emissions in pipelines. Just a few last words from Atlantis. The company is chaired by Jean-Jacques Dordain. We have in our advisory board people like Guy Duchossois from the former European Commission officer, Son O'Keefe from NASA, and some other members of our investors like Fernando Impuesto from Enagas, and some people in the Spanish government. The investors are institutional, so 23% of the company is in the hands of the Spanish government, CDTI, which is the acting space agency in Spain, and the private investors are on top of the entrepreneurs, Enagas as the leading investor, and a pension fund. So this is my message. As a conclusion, perhaps I would like to remark that today we have a great opportunity to look at assets before we launch a satellite, so we can understand what is the maps of deployment for a gas company in the world, where are the wells for oil, where are the electrical lines in high power, and we can have this global perspective that can only be provided through satellite in some sort of additional SCADA of a infrastructure company that is protecting the operational assets in the planet, even in offshore situations, that these infrastructures can have a mission that is properly monitored through the appropriate orbit, and then we can select trajectories, not only tasking points with very limited capacity, but actually following full structures with few limitations in terms of the maximum accelerations that the satellite can support, because our cameras are working with microseconds aperture times that have no need to stabilization and can also be monitored to focus into particular spectral focus detection, like 1.7, 2.2 for methane, or 0.7 for potassium, etc. So that the customer will have a really well-defined and precise solution that can solve the problem. And we will stop this behavior of launching constellations that have no customers. I think this is the old times, and some perhaps market inertia is still imitating this old behavior. I think today the healthy behavior is to conceive space as a normal sector that asks for customer requests and provide hardware, software, and services solutions to the customers' demands. And when we do that, I think we have a healthy sector, healthy companies, and satisfied customers that will provide the future. Thank you very much.
Okay, thank you very much, Juan Tomás. But I have a question for you. This is in line with your message. You have developed this kind of technology, such as the camera. Which are the major downstream services sector which you envisage for your technology? For example, defense or environment monitoring?
Okay, thank you, Christina, for the question. I am accepting that we need to start thinking of the customer challenge first. So we should talk about what is the problem before we talk about the technology. And we think that the customers that need satellites and cannot solve the issue with alternative technologies is clearly defense. So it's a first sector. We have 2 projects in defense for submetric below 50 centimeter inspection from the European Defense Agency. So this is clearly a very first sector. And especially when I talk about agility, moreover, that we have to follow a frontier line. So clearly, this is the first step. There is a second one, which you mentioned, is environment. The challenge in the environment is more related to the spectral focus capacity to understand gas emission phenomena. So where is SO2, where is methane showing up compared to clouds and compared to CO2, etc. So we have to see the points where we can really look at the methane emission and, of course, model the atmosphere, because the atmosphere is transforming the whole measurement. So yes, this is, a topic, and I cannot see any other way to regulate emissions if satellites don't provide an homogeneous method of registry every day, every week, with the same methodology, with the same serial measurements at this type of accounts. And I think the third one will be, I think, the energy sector in general. So electrical companies, oil and gas companies that normally are multinationals with different challenges, different geometries, that they have sea farms for wind, or they will have thousands of kilometers of electrical lines that have to be co-living with the nature, with trees and the increasing of vegetation. I can hardly see other methods rather than satellites to constantly monitoring those advances. So I think these are the first sectors to welcome. Are they doing it? I think to a very limited extent. So this is going to be the new economy development through this sort of approaches with high revisit through small sats and with high agility through small sats. So I think this is to come.
Okay, thank you very much. Now I move to the other speaker, where I am the honor to introduce Mr. Maurizio Cheli, astronaut. Currently is a board member of the Italian Space Agency and a member of the board of directors of the Italian Center for Aerospace Research. I leave the floor to Mr. Cheli.
Okay, thank you so much for this introduction, and being the last one today on a Friday evening, well, I just ask for your patience and bear a little bit with me. Today we will talk about Skymetry, which is basically a project which was developed and born inside a small company called DigiSky, which I founded a few years back, more than 15 years ago, with a friend of mine. Basically, I spent all my life in the aerospace business. I was a test pilot for the Italian Air Force, then for the today Leonardo, former Finmeccanica company, for more than 15 years, and I developed from the operational point of view the Eurofighter Typhoon. And I had the chance to fly in space, which basically gave me a different sight about, a different overview about flying. But being so passionate about flying, of course, I always loved small planes, because basically with them you can definitely enjoy the real essence of flying. And with a friend of mine, as I said, we developed this company, which was basically a startup in 2007. And it was incubated inside the Turin Polytechnic incubator, I3P. And basically the basic idea was to transfer into sports aviation
some of the concepts, basically engineering and designing concepts that you could only find in much bigger companies. We were immediately attracted by electric and hybrid propulsion systems, and in 2009, it's a long time ago when I see this, basically we developed a full electric aircraft called Skyspark, and with that I basically set a record for the type of machine during the World Olympic Games in Torino. But today I noticed that electric propulsion has become a big thing and probably the next milestone for aviation. We also worked with bigger companies, and one of the landmarks for us was basically being able to participate in a rather big regional Piemonte regional program called SMAT, basically dedicated to the development of advanced land monitoring system. And within this project, we developed a concept called Smart Bay, which was basically a pod in which you could accommodate a wide variety of sensors. And the idea was to use small planes, either sports planes or general aviation planes, in order to be able to do land monitoring. Why that? Because, of course, we all know the value of satellites, and today we also know the value of drones. But satellites are in general very expensive. They are not very agile. You need to wait for their revisit time. And it's not so easy to access information. And drones, which were only developed much later, of course, have a very small payload. So we thought at that time that general aviation airplanes could be a good compromise between the kilograms of payload you could carry in the region of 100 to 150 kilos, which is a lot today with today's technology, and the cost. Because certainly the price to access satellite images is still very, very high. So we started developing this system on our own. And in 2017, we were lucky enough to have Uptake, which is the Italian Aerospace Logistics Center located here in Torino, which basically provides logistic support to the International Space Station, but also serves as a data processing and data storage for a lot of space missions. So the ability to cooperate with them for us was a big thing. They entered with around 25% the capital of the company. Well, we all know that one of the main ESA goals today is Earth observation, and this is where we basically developed this program. We know that the value of satellites, because we've been talking about this the whole day, and but they have some intrinsic limitations which are listed here. Of course, the revisit is imposed by orbit. Resolution, at least for civilian uses, is also limited by distance. We have atmospheric interference and then sensor configuration, and main constellations are also public. So we wanted to use, as I said in the forward, basically to use general aviation airplanes and utilize them as a magnifying glass. I think these two words really describe the underlying idea behind Smart Bay. So basically, we wanted to integrate, to have a system which could be able to integrate satellite images with manned or unmanned aircraft data to overcome some critical issues which are linked to satellites limitation. Because of course, we can have a higher resolution because we can, even if the sensors might be on a lower grade, but we can fly much lower than a satellite, of course. we are talking about a few hundreds of feet, so between 100 to 150 meters over obstacles. We have a high repeatability, and we can basically take off on demand, provided that the weather, of course, is nice, because we need to fly VFR, so we need to be able to see outside. And as I said, Smart Bay provides a very easy mission reconfiguration, because the idea was to basically certify the whole envelope of possible sensors, and so being able to fly with one sensor, land, and if the case required, remove the sensor, install a new one, and repeat the flight in a matter of hours, or less than hours. So, as I said, the underlying idea was to use it as a magnifying lens. We went, basically, the Smart Bay is our proprietary technology. Is basically, we developed a structural wing pylon with a mission computer linked to it, and we provide a multi-sensor suite with the crew operator deck. We can install a lot of different sensors, as you see them listed here. They are all gyro stabilized, so we can have photo cameras, video cameras, laser scanner, chemical sensors, hyperspectral, multispectral, or whatever other sensor that potential customer might need. The idea is to use this is what you can observe here is basically the circle of the information, like starting from the bottom left. An end user located everywhere in the world can just send a request for some Earth observation need to a web-based service. So the idea is to develop a franchise system with we provide the main system, but people are able to work on their own. So there will be some kind of network around the world. For the moment, we are in Italy, and we are trying to expand in Europe. And so an airplane will take off and will use the Smart Bay with a selected configuration of sensors, and will plan the mission and the flight, and will execute them. The data will be sent back to our system here in Torino. They will be processed, and useful information will be sent back to the customer. The flight capability, of course, is very agile, as we heard from other presentations. But nothing is more agile than an airplane. Basically, we are able, because of also the speeds at which we fly, we are able to contour basically and follow any possible highway, roads, railways, pipelines, power lines, and also follow orographic details like rivers, coasts, and boundaries or borders. There will be basically, it will be very difficult to find spots which will basically impose maneuvering limitations to an airplane of this size and this speed. In this slide, basically, you will see the main characteristic of the three systems that today we are talking about: satellites, airplanes, and drones. Of course, we all know the usefulness of satellites, but they can cover a lot per hour. But they not always they offer stereoscopy, and of course there will be, especially in the visual range, there will be a lot of interference by clouds. I leave airplanes alone because a lot of people today talk about drones, and they think that they are the panacea to a lot of Earth observation problems. But of course, drones are very limited. If you look at the productivity, they can cover between 10 or 50 acres per hour. While in an airplane, we can fly from 500 to 5,000 meters. Basically, we can fly wherever it is required because the airplanes are certified. And we can cover a width of between 100 and 1,000 meters, and therefore cover between 1,000 to 15,000 hectares per hour, which is a lot, at a cost of a few hundred euros per hour, per flight hours, with the payload, as you will see there, in the order of up to 150 kg. The main clients, of course, are what you can imagine, solar plants, whoever needs Earth observation and data, georeferenced data of certain kinds. So power line companies, forestry, railway companies, and large infrastructure like pipelines, and also environmental risk management. In this, I will also include insurance company, because they might have a need to basically freeze a situation after a flooding or a fire or any other natural catastrophe. And of course, some municipalities, and we all know why they would like to have detailed data of the ground and the land, also for taxes sometimes, not always for this, but principally for this. So Skymetry, based on our smart base system, is a scalable business. As I said, we will use a general aviation fleet, and basically this pod with its pylon can basically be installed on any general aviation airplanes, and there are many general aviation airplanes around. So any small plane could become an Earth observation plane. Smart Base patented as EASA certified, and which basically makes a huge difference between an airplane and a drone, because we are allowed to overfly populated and inhabited areas, while with the drones, not always you're allowed to do that, depending on the size and the weight. And we are trying to develop a franchise network of aerial work companies. This is just one of the project that we accomplished during the last part of this year. We flew about 450 hours, and we were tasked by a solar company to inspect 850 solar plants. And with 7 pilots, we flew it with a thermal flare. And we were therefore able to detect, after data analysis, the fault of any or of a potential photovoltaic cell inside a solar plant. So a photovoltaic plant. So this gives you the idea of the detail we can go down to. As I said, we are a small company, but we are eager to develop. And these are some of the people who are working there. And this basically, we are also working a lot with the Turin Polytechnic University in order to develop the systems, data management system, etc. Furthermore. This basically concludes my presentation. In case you have any questions, I will be happy to answer.
Okay, thank you very much, Mr. Cheli. I have a question that is related to your experience as an astronaut. We are talking about asset in space, and in this sense, we think about satellite, orbiting station, launchers. However, if we imagine a different point of view, the man is an asset as well to protect in the space. How do you plan to protect the man or woman in view of long staying in the space? For example, now we are talking about the man return to the moon.
This is a huge question, and a lot of technical people are working on it, because we all know once you start flying far away from Earth, low Earth orbit, you are basically outside the Van Allen belts.
you are going to be exposed to radiation, and we don't know the long-term effects of radiation. But in the project now that there's a project to go back to the moon, I'm pretty sure many of you have heard already about Artemis program, and they have found already several solutions. Water could be one, or also using moon terrain to protect colonies on the moon. This is definitely going to be a problem once we start flying way far away from the moon, maybe on to Mars. And this, I think we still don't have a good solution or a definite solution, but technical people or engineers are working on it, and I'm pretty sure they will come up with some kind of solution that will allow people to move on to other planets, which will be a dream.
Thank you very much. Thank you very much. Now we have touched many elements and so different point of view. So asset protection is a topic of a great interest that can create an opportunity to address the important issue of sustainability in space. I would like to conclude the session to say thanks to the panelists, to the organizers, and to the audience. And I would like to say that tomorrow morning it will be the session finance, and the chairman is Mauro Piermaria of the Italian Space Agency. Thank you and have a nice evening.